All right, we had some technical difficulties, so I get to do it again. Hello, my name is Mitchell Pearson, and today we're going to be doing the DAX workshop presented by Pragmatic Works. If you want to reach out to me, either through email or my YouTube channel or through my blog, please feel free to get that contact information that you see on the screen. If you like what you see today, I do a lot of bite-sized kind of Power BI and DAX videos on my YouTube channel, and I'll be releasing a new one every week. So subscribe there and you'll be able to see a lot of those as well. I am the training manager here at Pragmatic Works. My role includes building new classes for Pragmatic Works as well as delivering live training events similar to this. Not quite as huge as this event, but similar to this in our live DAX boot camps and other boot camps that we do. I'm super excited to be here today. We have people from all over the world in the chat. So thank you for being here and attending this workshop, and I hope it's helpful for you. All right, we're going to jump right in, and we're going to talk a little bit about logistics for this. This is going to be a 3-hour workshop. We'll have a 15-minute break around 12:25 Eastern time. So that's going to be in about an hour and 20 minutes from here. And then this session, fortunately, will be recorded. I know that's going to be one of the #1 questions that we get. This will be recorded, and you can find that online at the YouTube, Pragmatic Works YouTube channel. Questions? Good. We're going to have a lot of questions coming in throughout. And so in order to make sure we don't disrupt the flow of this workshop too much, I'll try to answer as many questions as I can after we take that break. And then we'll do a follow-up blog and possibly a YouTube video that's focused just on those questions specifically as well. If you have a very targeted specific question, once again, please feel free to send me an email. And that brings us to the next thing here, which is following along. In your class files, which I'll talk about on the next slide, I've provided you the files you would need to try to follow along today. But I kind of would discourage you from doing that, only because sometimes it's hard to follow along, especially with a programming language, and I don't want you to get frustrated. This is recorded. You're going to have all the class files, so you can go back through this at your own pace and go back through all of the demos that we provided. But if you want to follow along, you definitely can. I would encourage you to have at least 2 monitors, one to watch what I'm writing, and then one so that you can work on yourself. And then, of course, let's talk about the class files. So in the files that you downloaded, and if you didn't download them yet, my coworkers are going to put that in the chat window for you right now. There's going to be about 5 different files that exist in there. One is a README file that just tells you about the different files. One is going to have the DAX workshop slides in a PDF format, so you have that available as well. And then there's going to be a code examples file. I was going back through the demos before today, this morning in fact, and I noticed I wanted to change a couple of quick demos around. So I did, and then I re-uploaded that to the class files, the attendee files. And so if you have one that says DAX Workshop Code Examples, that's the first edition. So it's not exactly the same as the demos I'm going through today. So you'll want to download that again. And then we have a data model. Now that data model is the starting data model, so you can follow along if you want, or go through these in a review fashion after the class is over. So you'll open up that data model, and then you'll just follow along with the examples that I'm doing, whether that's live or in the recording afterwards. And then, of course, I provided for you a completed example. So maybe you just want to open up that completed example, jump right in, look at the code that we're doing. That'll work great as well. However, if you want to open up either one of these files, they were created in the September 2020 version of Power BI Desktop. So you would need that in order to follow along or in order to open up those Power BI files. To get the most out of this class, you do not have to follow along. Just come along the journey with me, and we're going to write DAX and have fun. All right, so let's take a look real quick at the agenda. We're going to be taking a look at just DAX Fundamentals. A lot of the people that are in here today are going to be brand new to this language called DAX. So what do we use it for? Calculated columns, calculated measures, what are they and when do we use those? We're also going to start kind of building a foundation here for authoring more intermediate and advanced level DAX. So what is row context and what is filter context? Those 2 items together make up something in DAX called evaluation context. And then we'll do some stuff around time series analysis. So we'll take a look at year-to-date sales and prior year calculations as well. And then semi-additive measures, and then we're going to dive into context transition ever so slightly at the very end. If you like what we're going through today and you really enjoy this format, I would encourage you to take a look in the description of the video link at our DAX boot camps that we have coming up here in the next couple of months. And maybe you sign up for that and you get 3 days of hands-on experience in a more intimate environment where we can ask questions and work together. All right, so that's the agenda for today. Let's jump right in. We got a lot of material to cover. What is DAX? Well, DAX stands for Data Analysis Expressions. And this is the expression language that we use when we're working in Power BI Desktop. Now today I'm going to talk a lot about Power BI Desktop, but many of you are probably not even in Power BI Desktop. Maybe you're working with SSAS tabular models or Power Pivot. When I first started working with DAX, it was about 7-8 years ago, and it was when I was actually building analysis services cubes in Microsoft SQL Server technologies, right? It was before Power BI Desktop was really a thing. So you can definitely use everything that we're talking about in this workshop today, whether it's in Power Pivot for Excel or in SSAS tabular. Why do we have DAX? Microsoft has lots of programming languages, right? Well, DAX was designed specifically to support a larger user base, and Microsoft did an incredible job with this. You look at the hundreds of thousands of Excel users across the world that are already familiar with the functions in Excel, and DAX is very similar to that, at least when you get started. And so this is designed specifically to help those data analysts get up to speed a lot quicker. Now, this is a great tool for us IT professionals as well, but it's really an end-user tool. And that's why we have DAX. It's just such a better language than those traditional languages as far as being able to learn it and get up to speed very, very quickly, which I hope to demonstrate in this workshop today. So what is DAX used for? Primarily, we use DAX for calculated columns and calculated measures. Calculated columns are where we go in there and we add new columns to a table. Typically, we do that so that we can describe our data a little bit better, right? So it adds analytical value by giving us additional ways to describe our data. For example, if I'm looking at total sales and you want to see sales by age demographic or by age breakdown, then we would go over to our customer table, and if we don't have that column already, we would create that new column, and that would give us a descriptive slicer that we can use in our reports. I recently did a video on YouTube around the last working day. How do we always show our Power BI report to show the last working day when we come back to work or we come to work the next day? That also is a great example of building a calculated column in data analysis expressions. Another common use case for building calculated columns is when we want to build a relationship between two tables in Power BI or in the tabular model. And we do that by maybe having to combine multiple columns together first. I'll talk more about that when we get to that demo here in just a little bit. We're also going to be using DAX to build calculated measures. Now, calculated measures is really where you'll spend the bulk of your time writing DAX, and this is where we build those dynamic aggregations. So things like total sales and product cost and profit and margin and all of those kind of metrics like that. We also use calculated measures to build ratios and percentages, to build time intelligence calculations, year-to-date sales, year-over-year sales, prior year sales. So if you want to do analysis across time, we do that with calculated measures. And then there's also this concept of kind of complex relationships in DAX. And so we handle those also with calculated measures. One point on calculated columns that I want to talk about from a best practice perspective, it is recommended as a best practice when you're working in Power BI that if you can, you actually create those columns before you bring them into the Power BI desktop application, only because it can give you better compression. And so one of the things we recommend with that is if you can build it back in your SQL Server table, back in your Excel file, or in the Power Query editor, build it further upstream before you bring it in, you can get better compression from that. But if you have a small data model, you're building a proof of concept, don't worry about it, just go ahead and use DAX. That'll definitely work fine as well. All right, and then also you can use DAX to create calculated tables. Calculated tables aren't something you'll do quite as often as calculated columns and measures. I like to use them for a couple of purposes. One, maybe I build a calculated table that's an aggregate of an existing table. So I get an aggregate table that helps me to improve query performance. The other thing that I'll use a calculated table for might be to build a date table. So if you don't have one, that's a quick and dirty way of kind of getting a date table in your model. And also I love using calculated tables just for being able to debug and validate my code. Unfortunately, today in this 3-hour workshop, we won't be jumping into calculated tables because you won't be doing that much with them anyway. So let's jump to the next slide and take a look. All right, we don't have a lot of slides in this workshop. I think I have 14 total, so don't be too worried about this. With navigation functions, what they allow us to do is they allow us, when you're building a calculated column specifically, go over to another table, grab a column from that table and add it to the table that you're currently on. And so navigation functions are very similar to like a VLOOKUP if you come from Excel, very similar to a join if you come from a SQL Server background. And so when you're using navigation functions, there's really two functions that are available. There's the related table and then the related function. And we'll take a look at both of those in our demo as well. The one thing that's kind of tricky about this, for those of you that have been working with DAX for a little bit and you're used to that automatic kind of filtering that happens through the data model, then you build a calculated column and you're like, wait a minute, it's not automatically filtering, what's going on? We're going to talk about that as well, but that's why we need these navigation functions to go over there, grab that data, and bring it over. Now, keep in mind, we're not covering the full breadth of everything you can do in DAX here today. Navigation functions you can use inside of calculated measures as well, but that's another topic. All right. Requirements for using navigation functions. A relationship must already exist within your data model to use them. If a relationship does not exist, then you need to go ahead and use it or create that relationship in advance, or you would use some other function like the lookup value function. Keep in mind, related and related table will typically perform better from a performance perspective than lookup value. So build a relationship and use related if you can. All right. So we're going to jump right into our Power BI model now, and we're going to write DAX. This is the exciting part here. And we're going to start off with some pretty basic examples, but we're going to go a little bit deep pretty quick as well. And that's for the more advanced audience that we have here. So let's jump right into Power BI Desktop and take a look. What I've done here is I am opening up the Power BI Desktop file that you saw when you downloaded and you saw in my PowerPoint presentation. So this is called DAX Workshop-Data Model. Once again, if you want to open it up, you do have to have the 2020 September version of Power BI Desktop to do so. So with Power BI Desktop open, the first thing I want to do is we're going to create a new calculated column. And so I am over here on the very left side of my screen going to click on the data view. And when I go over to the data view, I'm going to create a new calculated column on the customer table. And this will give us a chance to just review some of the fundamentals of writing DAX. So I'll right click on the customer table. And when I right click right here, I'm then going to select new column. And that's going to give us an opportunity right here in the formula bar just to start writing DAX. The first thing that we want to provide here is going to be the name of our column. So I'm going to type in here full name equals, and then I'm going to do a single quote. Now, one of the great things about DAX is that automatic functionality where it auto-completes your code for you or it gives you IntelliSense. And whenever you see IntelliSense, that's a good sign that you're writing your code the right way. And so I'm going to go ahead and hit Tab on my keyboard to let that auto-complete. And then I'll do an open square bracket, and then I'll type the first letter of the column that I want, which is the first name column. And then I will hit Tab again to let that auto-complete. Now, in that DAX workshop code example that I gave you, if you're following along, you can just copy the code out and paste it right in here without having to try to type it, and maybe you miss a comma or a closing parenthesis. That's why I provided that file for you. So we have the customer first name. Now we want to add a space, and then we want to add the last name. So the way that we can combine strings together in DAX is we use the ampersand operator, which is just above the 7 key on my keyboard. And then we're going to add in a blank space here using the double quote. So double quote, space, double quote. And then we'll add another ampersand sign. And now I want to bring in the last name from my customer table. So we're going to bring in the customer. And then right there we see last name. So I'll hit Tab again. And that's it. That's our very first DAX example. And as you can see, it's pretty straightforward. So the great thing about calculated columns is as soon as you kind of complete that expression and hit enter, you can see the results right away in your table here. And so right away we see our results and we know it's working. This is awesome. This is a little bit different than calculated measures, which we'll talk about when we get there. But now we can validate that. But now I'm going to ask you the first question of the day. When we created that calculated column here, customer first name, how does it know to take the first name from this row? Because technically in this customer cells or this customer table, we have 18,484 rows. How does it know to take that first name from that row? How come it doesn't choose some other first name? And it seems like a very intuitive and obvious answer, right? Of course it does, because I'm creating a row on the side. It does that in Excel. But what's happening when you create a calculated column is it creates something called a row context. And that row context allows the calculated column to essentially perform operations on that table one row at a time. So it goes to the first row of the table, it performs that expression. And since it's only performing an expression on that row and it only sees that row, that's how it knows exactly what first name to use and exactly what last name to use. And so at its core, row context is actually a really simple concept. Now maybe you've read a book or you've watched some videos and you've gotten a little mixed up on different evaluation context. In this workshop today, I want to cover the foundation and kind of the fundamentals around that. So that's the first thing. Whenever you create a calculated column, a row context is created and it works on one row of the table at a time. In programming, we call that iterating over a table. There's another thing I want to talk about here that's very important. Whenever a row context exists, the filter that is on the row of that table is kind of deactivated. This is a good thing, sometimes it's a bad thing, but we're going to talk about that. So for example, what do you mean filter that's on that row? Well, when you're working in Power BI, you create relationships in your data model. And that tells Power BI how to filter tables, right? So for example, if we come over here and look at our data model real quick, let me just simplify this ever so slightly, we'll notice that we have a relationship from our date table to our internet sales table on the date value. So we've built a relationship where the date table filters internet sales automatically on that order date. However, when we're working within a row context, that relationship is almost non-existent and it's been deactivated in some way, which you'll see here in just a moment. And we're going to talk about why we need those navigation functions to bring that relationship back to life. So let's go back over to our table real quick. And back on the customer table, we've created a row context because it's a calculated column, and that active relationship has been deactivated. Keep in mind that most people, when they think of row context, they immediately go to calculated columns, but row context also exists when you're working with certain functions in DAX as well. So the filter function, what it does is it works over a table, working on one row at a time, performing an expression on every row of that table. It also, if you're working with X functions, they do the same thing. Their first parameter is a table, so they also will work on one row of that table at a time, and that also performs a row context. If you understand and know when a row context exists, that's going to help you write and author more advanced DAX calculations. All right, let's jump into our next example here, another simple example, and we're going to, on our customer table, we want to be able to analyze our data by age breakdown. So in this table, we currently have the age column, and that's not good enough. We want to take their age and we want to bucket that, if you will. We want to kind of bucket that into an age bucket. So if you're over 55, you're 55 plus. If you're over 45, you're 45 to 54. So let's create a new calculated column on our customer table. Once again, all the way over here on the very right, I will right click on the customer table and I'm going to choose that I want to create a new column. So I'll create a new column here. And in order to build this age breakdown calculation, we are going to use some conditional logic in DAX. So this will be our first look at that here today. We'll create an age breakdown calculation. And we're going to say that age breakdown equals, by the way, whenever I go down to the next line in DAX, I always use Shift Enter. This kind of auto formats your code and it's really awesome. And as you see there, I actually commented out my code as well. And that commenting of code is ignored by the data modeling engine when it processes that expression. So now I'm going to tell it if, I'll hit tab and then Shift Enter down to the next line. Another really cool thing about DAX is that IntelliSense that you see right there. Whenever you're using a function in DAX, it gives you a description of what that function does, and it tells you what parameters are expected. So the very first parameter here is a logical test. And my test is going to be if the age of the customer is greater than 55, then they're 55 plus. So we'll type in here, if the customer and then age is greater than or equal to 55, then that customer is going to fall into the 55 plus bucket. And then we do the next one, right? So our next condition is if the customer age is greater than or equal to 45, they're 45 to 54. So the thing about this, actually, I'm going to clean this up and format it a little bit better here. And then I'm going to go down just so it's easier to read. And so we're going to say if the customer age is greater than or equal to 45, then the customer is 45 to 54. And then we'll do another condition here, right? So if that evaluates to false, if they're not equal to, if they're not greater than 45, if they are 45 to 54, if they're not, then we're going to do another conditional operation here. So then if the customer, age is greater than or equal to 35, then they're going to fall into that 35 to 44 bucket, right? And then if they don't meet any of those criteria, we're just going to say everybody else is 18 through 34. So that's our ultimate result if false criteria there. And we'll say everybody else is going to be 18 through 34, double quote. And then because we have a bunch of nested if statements, you probably know this from Excel, we need one closing parenthesis for each one of those, which in this case is going to be 3. Now let's take a look at this code real quick. I'm going to hit enter, so we'll be able to see the validation of that over here on the right. Now, the astute student would probably notice that when you get to the second pass right here, that we're not actually adding an upper threshold, right? We're just saying if the customer age is greater than or equal to 45, they fall within the 45 to 54 bucket. But you might know that if somebody were 57, they're greater than or equal to 45. If somebody were 90, they're greater or equal to 45. So is this expression correct? Well, the answer is yes. Yes, it is. Because the way that DAX works is it uses the first pass rule. So any of those customers that are 55 or older, when they went through this very first condition, they were eliminated from the result set. So then when we're looking at the next result here or the next expression, we only see the remaining customers that were not assigned a value in that first pass. So this is a valid expression. And now we can go over to the right side and we can see right here the result, and we can do a very quick breakdown here. So all of these appear to be 35 through 54. This one is an exception. That's 45 through 54. And so you can go through and do a quick test, but this is our first conditional operation here in data analysis expressions. All right, so like we talked about before, one of the main reasons we create calculated columns is because we want to create new columns on our table that help us to really add analytical value to our data model so we can describe it in different ways and slice our data in a number of different ways. Let's create another calculated column. This time it's going to be on the date table. So over on our date table, we have another user request, another business requirement. And this time I want to create a new column on the date table. So make sure I right click on that, create a new column. And I want to create a 2-digit month and a 4-digit year. So we'll call this our month year. And this, by the way, will look great. There's a couple of reasons why you might want this. One is because it could help your DAX calculations when you need to be much more specific in a kind of authoring a more intermediate or advanced level calculation. Also, this is going to look great on like a column chart when you're looking at data across time because you'll have the 2-digit month and the 4-digit year together right there. So our goal here is to return the 2-digit month with a dash, and then the 4-digit year. A really easy way to do this in DAX is by leveraging a function called the format function. Once again, as soon as we type in that function, I hit tab to autocomplete. The definition of it is it converts a value to text in the specified number format. Essentially what this does, it'll let you take either a date value or a numeric value and format it in a very specific way. Now there is a side effect of format, which is it will take that value and convert it to a text value. So it does do like a data type conversion here as well. And so I'm going to do Shift Enter to go down to the next line. And then I'm going to provide the value. The value is going to be the date column from my date table. And we want to take that date value and we just want to extract from it the 2-digit month and the 4-digit year. Now we're going over format very quickly here, but as you explore this yourself, you're going to find out this is extremely customizable. So we're going to do a 4-digit month. We'll add just a regular string dash right there in the middle. And then we're going to tell it that we want the 4-digit year, closing parenthesis right there at the end. And this gives us exactly what we want for our business requirements. If I did the 3-digit month here, right? So let me put a little comment. If I did the 3-digit month, this would return for January, Jan. If you did the 4-digit month, it would actually return the full month. So you would see something like January right there. And so it's a very, very flexible solution. So we'll go ahead and hit enter, and then we'll go all the way over to the very right here. And we'll see we got exactly what we wanted, the 2-digit month and the 4-digit year. Now, as you explore DAX and you get more familiar with it and you get really more adept with it, you'll find out that you could have written this expression in a couple of different manners. And that's all part of becoming better at writing a language, right? And then you start getting more adept at it, you start performance tuning, and that's kind of that next level here. But this is a great solution for what we wanted in this situation. All right, we're going to go and jump into another challenge that we want to solve, and this is around the data modeling piece. We've been very fortunate at Pragmatic Works to partner with Microsoft in doing a lot of dashboard in a days, really internationally, whether it was live or through virtual events like this one here. And a lot of times when you're at a dashboard in a day, you get a lot of great questions from people that are brand new at DAX. And one of the problems that people have a lot of times when they leave dashboard in a day is they're pulling in data from a lot of different data sources. How do I connect that data together? That's a really challenging thing. So I wanted to give you an example in this DAX workshop, just in case you kind of fall into that category. So let's take a look once again at our data model. And I'm going to jump over to our temperature table, and we're just going to look at the data real quick. We want to be able to take a look at our total sales, our profit margin based on the temperature range. So what is our profit margin when it's cold? What is our profit margin when it's hot? So we need to build a relationship between our temperature table and our internet sales table. But in order to do that, what column do we build that on? Fortunately for us, in our temperature table, we actually already have a key column that exists right here. And so this right here is our key column. And a key column, especially if you're on the dimension side of the relationship, and I'll talk about what a dimension is here in just a little bit. But if you're on the one side of a relationship, that key column needs to be unique. So in this table, what makes a record unique is the combination of the region and then the month number. Now, we want to build a relationship to internet sales. So let's go take a look real quick at our internet sales table. So we'll escape out of there, take a look at the internet sales table. And on our internet sales table, we don't actually have the region name and we don't have the month number. Those don't exist right now today on the table. So instead, what we're going to do is we're going to have to add those columns to this table. So let me show you what we can do. Right here, you'll notice that we have our sales territory key. So if I want to know this transaction right here, whether it happened in the United States or Australia or Canada, or what region it occurred in, or what zip code or what city, we take that key over to the sales territory table. We find sales territory key of 4 and we say, hey, this happened in the Northwest region. So we do have what we need here to essentially do, if you were in Excel, what would you do? You would do a VLOOKUP. If I was working in SQL Server, I would just do a join to the sales territory table. I'd grab the region and I would bring it over. So how do we do this in DAX? Well, the way we do this in DAX is we're going to add a new column, obviously, on this table. So on the internet sales table, all the way over here on the right, I'm going to right click on internet sales and then select a new column, just like so. And this is going to be called our temperature key. So I'll go ahead and name that real quick to temperature key. And then how do we get that region from our sales territory table? Well, if I start typing in sales territory here, you'll notice that it doesn't quite work. IntelliSense says, wait a minute, I don't know what you're trying to do. And this is a good thing. If you see this, don't keep writing, right? Because it's just not going to work. I promise you that. It's one of those situations where the IntelliSense is so good, it kind of tells you when you're going down the wrong path. Even though there's an active relationship between the sales territory table and the internet sales table, there is a relationship that exists in our data model. We're creating a calculated column. And that calculated column means we're working in a row context. And as we reviewed before, when you're working in a row context, the active filter that's on that row is deactivated. So DAX doesn't see that relationship right now, but we can tell it to go ahead and use that active relationship by using one of those navigation functions. So I'm going to type in related, and then you'll notice immediately I see the customer table there. And if I start typing in sales territory, the sales territory table pops right up. So we're going to do that, and then I'll do an open square bracket, and then I'm going to grab the region from that table, close that up, and hit enter. You'll notice this is a little bit easier than a join or a VLOOKUP because we don't have to specify what that join is on or what the relationship is because that's already created in the data model. Related just takes advantage of the relationships that you've already built inside of your data model. All right, so this is related. Let's go take a look at the results over here on the right just to see if they look correct, and this looks really good. So if we click the filter here at the very top right, we can get a distinct list, right? I click the filter right there. We can get a distinct list of all the different regions that got returned from the sales territory table. This looks good. It looks like everything's working exactly the way that we expect it to. So with that being done, we need one more piece. We're not done. The other part of this is we need to return the month number from the date table. Now, you might think that you could just take advantage of the date that's on this table, the order date, and you could just extract the month from that. And in some ways, you're correct. Because right now, our active relationship is on order date. So that would work. But you got to be careful with that because we want everything to be dynamic in DAX. And if we use the month number from the date table, it's using the month number based on the active relationship. So if you built this data model and you originally built it with the active relationship on order date, you can go ahead and take the month directly from this table and you're totally fine. But if you later on change that active relationship over to the ship date table, then all of a sudden it's actually taking the wrong month from the wrong date if you hard code it here. So the method I'm going to show you is a little bit more dynamic and I would prefer. So look at this right now, and here's a good example. If you look at the first row, that month number of year is 12. But if you look at the ship date, that month number of year is 1 because it's different. It was ordered in December, it shipped out in January. And this is part of a larger concept that we won't talk about today, and this is role-playing tables. And so that's more of a dimensional modeling terminology. How do we handle that in DAX? Well, we won't get to that today, but that's a really good topic, and we do cover that obviously in other classes. So what I want to do is instead of taking the month directly from the order date, we are going to tell it that we're going to do an ampersand sign, and we're going to combine the region with the month number of year from the date table. Once again, I can't just type in date here. That doesn't work. So we need to use related so we can take advantage of those active relationships in the data model. So we'll type in related, and then we'll type in date, and then we grab the month number of year from that date table. And you'll notice it looks like I'm typing really quickly, but I love autocomplete. It's going to save me one day from having carpal tunnel. I just always hit that tab key and let it finish for me. So this right here is going to give us that exact key that we need on this table. Now, this does not solve all of your data modeling problems in DAX, right? This solves one problem where one table was set up and this fact table, the mini side of the relationship, it just didn't have the key that we needed, so we went and got the key. Sometimes you'll have many-to-many relationships and you have to build a bridge table. There's a couple of different ways that you have to handle these situations. We don't cover them all today, but this is one method. This is one method that's very good. So now if we go over here to the right, we have a temperature key and we can build a relationship. For now, we're going to skip that step because later on I want to show you what happens when a relationship doesn't exist. So a little bit later on in this workshop, we're going to come back and we'll build that relationship. But this gives us an introduction and it gives us some insight into navigation functions and what those look like. All right, let's take a look at another way of kind of working with this row context and then using navigation functions to get out of it. So we're going to do this one on our sales territory table. And this demo here is a little bit of an extra demo that wasn't in those original notes for the class. So you want to make sure you download those class files again to make sure that you get that DAX ready to go. And so on the sales territory table, we're going to create a new calculated column. Now here's the scenario. Our business users come to us and they say, hey Mitchell, we want to be able to see our total sales, our cost, our profit. We want to be able to see that based on the high volume region or low volume region or medium volume region. Well, we look at our sales territory table and we're like, well, we don't have an attribute or a column in that table that represents that helps us to describe our data in that way. So what we're going to do on this table is we're going to create that column. But in order to determine if a region is high volume or low volume, we either need to look at the total sales or total transactions or something like that. So we're first going to create a helper column, then we'll create that other column. So let's focus on total transactions first. And I think I call this one total transactions. Perfect. So we're going to create a new column on our sales territory table called total transactions. And I am going to just say count rows from internet sales. And this is not going to work, once again, because we're creating a calculated column and because we're working in a row context. So let's take a look at the behavior here. You'll notice that when we create this new column and we're looking at sales territory key of 1, which is the Northwest region, it's returning 60,398 rows, but it's returning that same value all the way down for every region. This is a clear indication that filtering is not taking place in our data model, not the way we might expect it to. Now we know, just after a little bit of time in this DAX workshop, we know that the reason filtering is not taking place is because this is a calculated column. We're working in a row context, and row context has disabled this key right here, right? So we have a relationship in our data model from the sales territory table to the internet sales table on the sales territory key, but it's not filtering it actively because a row context kind of turns that off. So how do we solve that? We are going to use navigation functions, either related or related table. Which one you use depends on what side of the relationship you're on. We are currently on the one side of the relationship in Power BI. The one side of the relationship represents that whatever you built your relationship on right here, which was on the sales territory key, that key in the one side is 100% unique. That's what makes it the one side of the relationship. A lot of times dimension tables, right? And I'm going to talk a little bit about that now, and I'm going to give you some context here. When we're building a data model in Power BI, the best way to build that data model is kind of like what we call a star schema in dimensional modeling technologies, right? Or that methodology. And a star schema is a transaction table that's surrounded by descriptive tables. A dimension table is a descriptive table that describes your data, and it's a bunch of related columns. So for example, if you were looking at your transaction table and you wanted to see total sales by product, you would go over to your product dimension, your product descriptive table, and you'd have all of your related attributes for a product in that table. The product name, the product color, the product weight, so on and so forth. And so when you're building a data model in Power BI, it's very, very recommended that you build it in this format because it's going to optimize storage and performance, and it's going to make your data model flexible. And when you build it in this way, the descriptive attributes, those tables, they should be the one side of the relationship. Your transaction table is the mini side because every time you sell a product, it's going to be recorded in that transaction table. So this is the one side of our relationship. The transaction table is the mini side. So since we want to go and get rows of data from the mini side of our table in our relationship, we're actually going to use related table. And what related table does is it returns a table that has all of the rows and all of the columns filtered down by the active relationship in the data model. So this right here will return all of the associated records for sales territory key of 1 from the internet sales table, which means it's not going to be all 60,398 rows. It's just going to be the 8,000 rows for that region. So now, once we have this table, we can now do our aggregation on that table expression. So we're going to count rows like so. Hit escape right there to get rid of that IntelliSense, and then let me format this just a little bit here so it's more readable. And now that is going to actually give us the exact result that we want. So row context is a great thing in DAX, and it allows a lot of things to happen. But if you're new, this can be a pretty frustrating situation because all I want to do is go get total sales. How do I get that? Or I just want to go get total transactions. And we do that by using related and related table. Now later in the class, at the very end, we're going to talk about context transition. It's quite possibly the most complicated topic in all of DAX. And so we won't dive deep into it, but there's actually an easier way to solve this problem with context transition, and we'll touch on that here at the very end. All right, so over here on the right, what do we get? We now get the exact results that we want because filtering is happening and it's giving us exactly what we want. Now this was the helper column. What we actually wanted here is we wanted to build a column that helps us describe our data based on low volume, medium, or high volume region. So we're going to now create another column in our data model, and it's going to be using another conditional type column, but we're going to use a different method. I want you to see things from a couple different perspectives here. So on our sales territory table, we're going to create a new column, and this column is going to be called probably region volume. Let me check my notes. There it is. So we're going to create a new column here called region volume, and then we're going to do some conditional logic. This time, instead of using if, I'm going to use the switch statement. If you come from a SQL background, switch is very similar to like the case statement in SQL. And so I'm going to type in switch, and then we're going to tell it true. There's a guy in the community by the name of Rob Coley. He wrote a blog called The Diabolical Genius of Switch True. He wrote it many, many years ago, and it explains why this works the way it does. But this is the expression that we're going to use. And we're going to say if our total transactions, so the column that we created on this table, if our sales territory total transactions is greater than or equal to 7,000, we're going to say that that is a high volume region, right? So we'll say high volume. And then we'll do another condition here. If our sales territory total transactions is greater than or equal to 4,000, then we're going to say that it is a medium volume region, which is perfect. And then we're going to do one more kind of condition here, and we're going to say, look, if the total transactions is greater than or equal to 1, then that falls into the low volume category right there. And then if none of those criteria are met, then we're just going to say everything else is in A. And this is another one of those kind of dimensional modeling terms, so I apologize because you might not come from that dimensional modeling background. In fact, most people that are working in Power BI don't. But what happens a lot of times is from a reporting perspective, if you get bad data in and you can't assign it to a certain product or you can't assign it to a certain sales territory, we still want to make sure we record that sale and we're able to report it tomorrow, right? We want to be able to show our boss, we did have 10 million in sales, but maybe we didn't know exactly what sales territory that was associated with because our data might be a little bit bad. So what we would do is in our fact table, we just assign that to in A, not applicable or unknown. And in this table, we have that. We have a dimension attribute or a member in this record that's in A. It's not applicable. We don't know. So if it's in A, you notice there were 0 transactions associated with this. If it's blank, we're just going to say, look, it's not applicable. So that's what we're going to do there. We'll hit enter real quick. And this is another way of writing a nested if statement. I think it's a little bit cleaner, easier to manage, and easier to maintain. So I really like this method right here. And then all the way over here on the right, we can do a quick kind of validation here and see that it's working exactly the way that we want. Now when we're building those visualizations and we're building those reports in Power BI, we can use this to kind of describe our data. We can use this as a slicer. We can put it on the x-axis in our report. We can put it on our rows and our columns in a matrix. This is going to work perfect. All right, so I think we're almost done with calculated columns. We have one more example that I want to talk about here, and it's another one that looks at row context, and it introduces a new type of function in DAX, which I'm really excited about. These are my favorite functions in DAX, and they're called X functions. So let's go look at the scenario here. We're going to go over to, finding my place in my notes, we're going to go over to our internet sales table. Actually, let's go back to the customer table. That's where I want to be. All right, on our customer table, we want to know the last order date of a customer. Maybe we want to build this kind of analytics here so our marketing team can do something with it. And you'll notice that on this table, we actually have the first purchase of each customer. So we already know when they made their very first purchase. That's when we entered them into this customer table. But now we want to know their last purchase as well. So we're going to create a new calculated column, and this is going to be our last purchase date. Now the way that we get the purchase date is, or in order, is we have to go over to the order table. We find all of the records for that associated customer in the order table, and then we get the last order for that customer. So how do we do that in a calculated column? Well, let's take a look. So on our customer table, and I'll escape out of there real quick. On our customer table, we're going to go ahead and create a new calculated column in DAX. So I'll right click and then select a new column there. And we're going to call this one just something very simple like the customer last purchase date. So we'll come all the way up to the top and type that in real quick, last purchase date. And then we want to go over to the internet sales table and we want to get the max order date from that table. So if I'm new to DAX and I don't know about row context and I don't know about that side effect where the active filter is disabled, the way that I would originally write this is I would just say, okay, there's a relationship in the data model. Just go to the order, just go to internet sales table and get the max order date for this customer. So I would type in here probably something like max and then internet sales and then order date. Just like that. And so I'm going to do that. I'll type in max internet sales order date, but what gets returned when we do that? If no filtering is actually taking place where this table is filtering down internet sales, that's going to return the very last order date from the internet sales table for every customer, which that's not what we want, right? So let me show you what I mean there. If we go all the way over to the right, you'll notice that similar to our total transactions when we were in the sales territory table, we're getting that repeated value again. That repeated value is always a clear indication that filtering isn't taking place. So not every one of our customers made a purchase or their last purchase on July 31st. Some of them made their last purchase 6 months ago or 3 months ago. And so we need to figure out what's the problem here. How do we solve that? Well, we do know that we're building a calculated column and we know a row context exists and we know the active filter has been disabled. So we want to activate that filter and we can do that with navigation functions. So what I would do here is we're on the mini side of the relationship. We're going to use the function related. So I would type in related. You guys have the completed example in your notepad, so you can just copy that out. And when I click on related, actually it's a related table. We're on the one side. Messed myself up there. We're on the one side. So what you do when you're on the one side is you go over and you use related table to get all of the associated records from that related table. So we're going to return all of the records for customer one, all of the columns and all of the rows. Now this becomes a little bit difficult in DAX. My favorite functions in all of DAX are X functions, min-X, max-X, sum-X, average-X. Let's talk a little bit about what they do. You'll notice that if I go to the very beginning here and I say, all right, we have a table. Now I want to get the maximum from that table. The max function, this aggregate function, only accepts a column name or a scalar value. So you cannot pass that related table that we just created. You can't pass that into the max function as a value, as a parameter. You can't do that. And so this is a situation where we have to use, if you don't know what context transition is, which we'll talk about at the very end, you would have to use an X function in this situation. So I would type in max X. Now, because I've been teaching DAX for many years, I know that X functions can be really confusing. So I'm going to take a moment just to explain kind of the breakdown of what an X function does. I like to think of X functions as two separate pieces. The first piece is the X part. And what the X part does is it takes a table and it works on one row of that table at a time and it performs an expression on every row of that table. So at the end, you get kind of a single column table as a result that gets returned. So in this situation, we're going to say, all right, we want the X portion to work on every row of this table that got returned, which is of course the related records for whatever customer we're looking at. And for every row that you perform, for every row that you're working on, return this expression. And the expression I'm going to return is going to be the internet sales order date. All right. So this is going to return a list of all of the order dates for each customer. Then after this part does its work, after the X function has looked at every row in that related table and it's returned the order date for every row in the internet sales table for that customer, Then the max function comes in and says, okay, get me the maximum date from that list of dates. So we're going to return the maximum date from that list of dates right there. And we'll hit enter. And then if we come all the way over to the right, we can see that we're not getting July 31st of 2008 for every customer. We're now getting the exact last purchase date of every customer here. And so if you want to come up with something like this in DAX, it's really easy to do. But of course, the hardest part there is understanding that row context that exists and how to work around that with navigation functions. All right. This was a little bit of an intermediate level topic here. So if you're brand new to DAX, I apologize for that. I wanted to throw this in here and kind of get you familiar with it because it does have some familiarity with Excel as far as being able to do that VLOOKUP type functionality. Go over to another table, get the data you need, and bring it over. And this is how we do that in DAX. So with that being done, we're going to transition over to calculated measures and talk a little bit about that. And so we'll cover the fundamentals there and then kind of build on that as well. And then if we have any questions, we're monitoring the chat. They'll let me know if there's anything, a common theme there, other than the fact that I'm going too fast and I need to slow down just a little bit, which I'm going to do. I'm so excited about DAX, I have a hard time controlling myself. So I'm going to slow down a little bit. I've seen a couple messages from somebody telling me to slow down, and I will do that. All right, so let's jump back over to the PowerPoint real quick and take a look at calculated measures in DAX. So with calculated measures, we're going to talk about a couple of different things here. One, calculated measures are phenomenal. This is one of the things that I think has made Power BI Desktop such an incredible tool. It was a couple of years ago, I was doing an architect type session with a company, and they came in and they really didn't want Power BI. They didn't want it. Their customers kept asking for Power BI, but they didn't want Power BI. And what they did is they essentially took a platform, they built a data warehouse on it, and they gave their customers pre-built reports. So it was a specific industry, right? And they wanted me to give them all the reasons why they might not want to use Power BI as a selling point to their customers. And so we go through this full day architectural session. I'm trying to talk down Power BI. And finally I said, you know, you're having this problem where you're having to go teach your customers SQL to try to modify existing reports because they want to make some changes, but you can't teach them SQL, right? It doesn't work. You can't do that in a week. Let me show you a little bit about what Power BI can do. And so I open up Power BI real quick, I create 2 or 3 measures, and I show them how dynamic and how those measures are automatically filtered. And in the next 2 hours, the entire mindset of that meeting shifted, and they said, okay, we need Power BI. How do we build this into our tool? So calculated measures are phenomenal, and I think this is one of the reasons why Power BI has exploded on the scene. It's not just those pretty visuals, it's how dynamic these measures are. So in this section, we're going to talk about filter context, what that is, what it does. We're going to take a look at calculate, which is without a doubt the single most important function in the entire DAX language. You want to learn calculate and you want to learn it quick. And then we're going to take a look obviously at time intelligence functions, doing that time series analysis, and we're also going to review semi-additive measures as well. So let's jump right in and take a look. So filter context in Power BI is simply, or in DAX rather, is simply the active relationships that you built in your data model and the way that they filter down the tables, right? So if you have a relationship from your date table to internet sales, then whenever you're showing your total sales amount and you bring in the year from your date table, it automatically filters that down. And so you don't have to write a bunch of different expressions to make that work. It just happens automatically in Power BI. And if you're working with tabular, it happens automatically there as well. And so what constitutes or what makes up that filter context? Well, it's really anything that's kind of in that report page or affecting that report. So it could be, if you're looking at a table visual or a matrix visual, it can be any attributes, right, that you have on the rows, any filters that you have on the columns of that matrix, those would filter down that value. If you have slicers, which are just visual filters in your report, those would also filter down that table. Or that measure, rather, it would filter down the measure. If you have filters in the filters pane, they're kind of hidden over there on the side. They're also part of that filter context. And then also, when we're writing DAX expressions, as you'll see here in just a little bit, we can also apply filters within our DAX. That becomes part of that filter context as well. So we're going to talk about that automatic functionality of filter context and how that works. But sometimes you don't want that automatic functionality and you want to override it or you want to change it or you want to modify it in some way. That's what calculate does. And this is why calculate is the single most important function in all of DAX. Calculate allows you to evaluate an expression within a modified filter context. So I say I want to see total sales, but not for the current filter. I want to see total sales for last year. So take whatever the current year is and modify it to give me last year total sales. Or I want to return total sales, but not for the country Australia that's on the row, return it for the United States instead. And so calculate allows us to kind of modify or evaluate that expression within a modified filter context. And it's really easy to use, and we're going to go through probably 15 or 20 examples, I think, today where we're using calculate over and over and over again and just exploring it in a couple of different ways. Now, we're going to use calculate to build things like ratios and percent of totals, to build very specific scenarios where we want to compare values. Also to do time series analysis, we'll use calculate quite a bit. The syntax for calculate is pretty straightforward. You're going to start with calculate, and then you provide an expression. That expression is generally going to be some form of an aggregation. So return total sales for this modified filter context. Return total cost for this modified filter context. The modified filter context you define in the filter section of calculate. So usually calculate is going to be, you start with calculate, you have an expression, which is normally an aggregation. A lot of times we're leveraging a measure that we've already created. And then just below that, we have a filter where we're filtering that down in some way. We're changing that filter context. And so this is the default value of calculate. Once you use it a couple times, it becomes very automatic, and it's a really, really cool thing. The other thing I want to talk about, and we'll get to this before the end of the day, this will be after we take a break today, is we're going to talk about semi-additive measures. Semi-additive measures is in your data model. That's when you have something that's additive across some dimensions. Remember we talked about dimensions earlier, those descriptive tables. It's additive across some descriptive tables, but not all. So most of the time they're additive across your dimensions, but they're not additive across time. That's the most common scenario. So let me give you a quick example. If you're looking at Mitchell's bank account on October, we're in October, so October 1st, my bank account might have $100. You look at it on October 2nd, I still have $100. And then when you get to October 8th, I still have $100 in my bank account. You can't add up my account balance for all 8 days of October, because if you do, it says that I have $800. But I don't have $800, I actually have $100. So that measure of my account balance is not additive across time. However, if you had 1,000 customers in your database, you could add that value, that account balance, you could add it up across all of your customers. So it's additive across customers, it's additive across other dimensions that you might have, but it's not additive across time. All right, so how do we handle this in Power BI? We're going to talk about that. Inventory levels, account balances, those are both very common scenarios where you're doing semi-additive measures in DAX. And it's a very common one. I see this all the time. How do I solve that? And then, of course, we're going to jump into time intelligence in DAX. We're going to do calculations like year-to-date, prior year, year-over-year sales. You can do things like rolling 3-month total, rolling 6-month total, running total for all time. And the beautiful thing about DAX, if you've done this in other programming languages, is that you can do this not in a couple lines of code. You can do this within just a couple of words of code. And it's just an unbelievable. I've done this in other programming languages. I've had to write tons and tons of code in SQL Server to build out time intelligence and then multiple variations based on how users wanted to filter the data. And then in DAX, I can write 3 words and I have all of my year-to-date across any way that customers want to filter that data, which is incredible. If you're doing time intelligence, and I'll mention this again when we get into the demos here a little bit later, there are a couple of requirements. One requirement is that you should have a date table in your data model. This is one of those. Another, I told you, we get to work with a lot of people that are kind of brand new to Power BI, brand new to DAX, and this is one of the biggest problems I see, is that they don't have a date table in their data model, so their time intelligence isn't working the way they expected it to, and they keep trying to rewrite the calculation, but it's not the calculations that's wrong, it's that they don't have a date table. So you want to make sure you have a date table in your data model, and that date table should have really 2 requirements. The first requirement is that you don't have any gaps. You don't have any gaps. So you say, well, we're not open on the weekends, we don't do business during holidays, we're not open on the summer, so we're going to remove those dates from my date table. Don't do that. You want to make sure your date table has every possible day that's available from January 1st to December 31st. You also want to make sure that your date table spans all ranges. So if you're bringing in transactional data that starts on, let's say, June 5th of 2017, then I want my date table to at a minimum go back to January 1st of 2015 and then go to the very end of this data, this current year as well, right? So all the way to December 31st of 2020. You might need more dates though. I'm working with a customer right now where we're building out forecasting data across multiple different fact tables and doing some other stuff with that. So we need dates that go a little bit further into the future there as well. So sometimes you will need more dates, but you want to make sure you span the range of all possible dates and you don't have any gaps. And that's going to help out significantly when we start doing that time series analysis and data analysis expressions. All right. There's also a ton of different functions that exist in DAX for doing time intelligence. Obviously, we don't cover a lot of those here in a 3-hour workshop. In our DAX bootcamp, in our on-demand training, we cover almost all of these. We cover a lot of them because they're very powerful and they allow you to do a lot of really cool things within Power BI and tabular models, of course. Like I said, I'm going to say Power BI a ton just because that's what I get to work with most today. But things like total YTD, that's going to return my year-to-date sales. Same period last year, that gets me my measure, whatever it is, for last year. First date, last date, things like parallel period, previous year, lots of really cool things we can do here. And so what we cover today is just a really small kind of scratching of the surface, what you can do with time intelligence when you're working within the DAX language. All right, so that right there, just to let you know, is the end of our slideshow. I wanted to get through the slides very quickly in here, kind of cover what we're going to cover, and then we just want to write a bunch of DAX. So for about the next 25 or so minutes, we're going to write calculated measures. We're going to look at that awesome functionality of filter context, and then we're going to go into calculate. We'll take a break, and when we come back, we're going to spend the rest of the day talking about calculate, how do we override filter context, semi-additive measures, time intelligence, all that great stuff there. So we're going to jump back over to Power BI Desktop here. And back in Power BI Desktop, when I create calculated measures, I generally do that from the report view. And the reason I do that from the report view is because unlike calculated columns, you don't actually see the value of your calculated measure in the table, right? Because it's dynamic. So there's not a static value. It changes as you change the filters within your report. Now, I do want to put all of these measures that we create on our internet sales table. And so I learned a really cool trick from somebody in the community. Matt Allington did a blog. I saw it on Twitter. So I want to give a shout out to Matt Allington for this right here. He went over to the model view, and what he does is he'll take all of the columns in his table and actually put them in their own folder. And I like this a lot because then my measures aren't getting kind of mixed up with all of my calculated columns. Now you can assign measures to their own folder as well, but then you have to go to each measure and keep doing it. So I like kind of doing the inverse here. So I'm going to go over here and grab all of the columns in my internet sales table. Now, in order to do this, you have to be on the model view and obviously have a newer version of Power BI Desktop. And so I'm going to grab internet sales here and go all the way down to the bottom, grabbing every one of those columns. And then in the properties window, in the display folder here, I'm just going to say, hey, put all of those columns in a new folder called columns. And we'll do that. And so they all get grouped up together. Now when we see our measures, as we create them, we'll be able to see those grouped together here as well. And I saw that we had a question here, or a lot of questions that came in about fiscal year to date and doing time intelligence around fiscal calculations. We are going to talk about that. So stay tuned. We will cover that. Thank you for throwing that out there. We will definitely jump on that as well. Now, let's go ahead and create a couple of measures here. The first measure we're going to create is going to be very basic, very simple. It's going to be the sum of sales amount from our internet sales table. So on my internet sales table, I will right click on internet sales, and then I'm going to create a new measure right there. And then up here at the very top, I'm going to call it total sales equals the sum of internet sales and then sales amount. So I'm just summing up a column from my internet sales table. And this is extremely powerful because I don't have to add a bunch of filters here for seeing it by 2005 or seeing it by a country. Because of the active relationships in the data model, this is going to kind of satisfy almost all of our reporting requirements, which is really incredible. So we'll hit enter. One of the things I'll always do when I create a calculated measure is I'll immediately jump in there and go ahead and apply some level of formatting. So up here at the top, we're under the Measure Tools menu. I'm going to go ahead and give this a currency of English United States by clicking right here next to the currency icon. And there we go. And then we're going to create about 3 or 4 more calculated measures. And then once we create those measures, we'll put those into a table, we'll put those into a matrix and start taking a look at filter context. So that's the first measure that we want to create. You'll notice that because we put all of our columns in a columns folder, thank you again to Matt Allington, we can now see our measures kind of separated from those right when we first create them. I'm going to go and click on Internet Sales again, right click. We're going to create a new measure. This measure is going to be our total cost. And this is going to be the sum of total product cost. So it's another column. We're just going to sum that up from the Internet Sales table. So sum Internet Sales and then total product cost, just like so. And we'll hit enter again, and then we're going to format it again. So like I said, we're going to be doing just a couple of really basic aggregations here. Now there is something else I should talk about fundamentally when you're writing DAX. In the DAX community, it's generally considered a best practice whenever you reference a column that's in a table, that you always put the table name in front of it. There's a couple of reasons for it. The most obvious is that a column name is not necessarily unique to a specific table. You could have the same column name in multiple tables. So in the DAX community, it's generally accepted as a best practice. Put the table name in front of it whenever you reference a column from a table. So that's what we're doing here. I put the column or the table name in front of it. And then we're going to go over here and format this one also as English Currency United States. Perfect. Now we have our total sales, total cost. I also think I skipped over total transactions, which is one that we definitely want as well. So we're going to create another one for total transactions. There's a few different ways you can build this measure. I personally, my favorite is count rows. So you'll see me use count rows quite a bit. So I'll go over to my Internet Sales table, and I'm going to right click and then create another new measure. This measure is going to be called our total transactions, very similar to the one that we created earlier on our sales territory table. And then in this situation, we're just going to type out count rows. I'll hit tab to kind of auto-complete that functionality there. And then what table do I want to count the rows from? Well, I want to count the rows from the Internet Sales table. So I'll type in Internet Sales here and then close up the parenthesis just like so. And this will return the total transactions from our Internet Sales table. So let's hit enter there. And perfect. Now we're going to create two more calculated measures. Then we're going to dive in and start taking a look at filter context. The next measure that I want to create is my profit. Profit is really just going to be total sales minus total cost. And so when you're creating measures like this, as a best practice, I like to reuse those measures over and over and over again when I write other measures. So I don't want to type out my total sales is sum of Internet sales amount when I can just use the total sales measure that we've already created. So let's go ahead and create another measure real quick and take a look at what that looks like. On my Internet Sales table, we'll create a new measure. And this is going to be, what do we say, our profit measure, like so. So we'll say profit, and that's going to be our total sales minus our total cost. And then of course, once I hit enter, I want to format it. Now you probably noticed a couple of things here. One, when I reference a calculated measure in DAX, I do not reference the table that it is assigned to. So calculated measures can be assigned to any table and they work just the same. So if you accidentally create a measure on the customer table and you're like, oh no, that sales measure should have been on the Internet Sales table, what you can do is you can select that measure, come up to measure tools, and you can just assign it to a new table. And so a very common practice in DAX for many years has been that we would create a table called our measure table, and we just assign all of our measures to that table. I don't personally do that anymore because now Power BI has given us the ability to assign our measures to folders within a table. So that gives me that organization that I want. But you can do that. You can assign them to another table and they work just fine. And one of the reasons for that is because measures must be unique. So I can't have a total sales measure on the Internet Sales table and on the customer table. It won't let you create the same measure twice. So you don't have to reference the table name. You might have also recognized that when you reference a measure, the text here is actually purple. And that's another indication just to let you know you're referencing a measure, not a column in a table. Now, when that's done, we'll go ahead and hit enter. And then of course, we want to go ahead and format this one as well. So as soon as it's done processing there, I will click the drop down next to currency. And then we're going to choose our English Currency United States, just like we did for our total sales and our total cost. All right, we're almost there. We want to create one calculated measure, and this is going to be our profit margin. Now, profit margin is going to be our profit that we just created divided by our total sales. And there's a couple of ways to do this. A lot of students that I see, or a lot of people writing DAX, they use the divide operator, where they just say profit divide total sales. The one drawback with that is that you could get a divide by zero case, right? You could get a divide by zero occurrence. And so I would recommend as a best practice that you use the divide function instead, because the divide function will automatically handle divide by zero occurrences. All right, so we're going to go over to internet sales. I'll right click on that table again, and we're going to create another new measure on that table. And then up here in the formula bar, we'll call this one our profit margin. And then once again, remember we could divide this a couple of different ways. You could have done this, which I'm not going to do, where you say profit divided by total sales, but this does leave you open to those divide by zero cases. Personally, I prefer to use the divide by function. So we'll say divide, we'll shift enter to go down to the next line. One of the things I love about shift enter is you see how it automatically indents the code, kind of saying this is the first parameter of divide, this is the second parameter. And then I am going to do an open square bracket, and then we will bring in the profit measure that we've already created. Now the denominator here is going to be our total sales. So divide profit by total sales. I'll do an open square bracket again, go down, grab total sales, and then I will hit tab to kind of auto complete that functionality. And then I'm going to do one more thing. Now there's this little known thing in DAX, which I'm going to start talking about now and kind of take us through this as we progress through the rest of this workshop. When you're working in DAX, a lot of functions have optional parameters. How do I know it's an optional parameter? You know it's an optional parameter because it's surrounded by square brackets. And so on the divide function over here in Power BI Desktop, you'll see that we're dividing the numerator by the denominator, but then there is an alternate result that appears right here within square brackets. And because it's in square brackets, it tells you that that is optional. You don't have to provide that parameter, but you can. Now, the way that the divide function works is that if it encounters a divide by zero case, it's automatically going to return a blank value. For me, that's perfect. That's exactly what I want. But you might say, well, if there's a divide by zero, let's just return the profit. Or if there's a divide by zero, let's return zero. Or let's provide some kind of text message that says divide by zero occurred. And that's an option as well. The only thing you need to be aware of is if you were to type something in here like divide by zero occurred, you're effectively changing the data type of that measure to be a text, which I don't want that to be a text because it's a percentage, right? So you got to be careful with that. In this situation, I'm going to opt to not use that alternate parameter. All right, so we'll go ahead and do enter. And then I was told to give a shout out here to Peter Smith, and Chuck Norris can divide by.
Zero.
Divide by zero. What are we talking about here?
Chuck Norris can divide by zero.
Oh my goodness. That's what that says. So Chuck Norris can do everything. Yes. And so another reason we like to do the shout out is because sometimes people don't think we're really live, which if you were here at the beginning and the volume wasn't working, you know we're definitely live. All right. So that is our profit margin. We'll go ahead and hit enter right there. And of course, we want to format this one as well. And that's going to be a percentage. So we'll make that a percentage here real quick. And we can now take a look at filter context. So we've created about 5 or 6 measures here. And we want to take a look at what does that look like when we start looking at that inside of a report, inside of a visualization. And so on this table, or inside of this Power BI, I already have a table kind of formatted the way I want it here. And I'm going to go and actually get rid of, over here on the right, in the visualizations, the way that you validate your measures when you're working in Power BI and you're building these DAX measures is we do that in the visualization pane. We start putting measures into visualizations, we start slicing them by different attributes, and we start seeing what those results look like, and we validate that they're working the way we expect them to. And so this is a very common way of kind of validating that. So what I'm going to do is I'm actually going to remove the year from the row for just a moment here so that we can see the original value of these measures before they start getting filtered. So I'll bring in my total sales, and then I'm just clicking on the little checkbox next to each one of these measures here. All right. So we have here in the value section, we have total transactions, total sales, total cost, profit, and profit margin. And when we go back over here and we look at this table, let me expand that out just a little bit more here. When we look at this table, we start to see that that is the sum, or that's all of the rows from our internet sales table. This is the sum of the sales amount column from the internet sales table. And this right here, one thing I like to start working on really early is kind of defining what that represents. What does that value represent from a filter context perspective? That is 29 million in sales. across all products, all customers, all dates, all sales territories, and all temperatures. Because right now, there's no filters that exist within this report. We don't have any filters on the rows, no filters on the columns, no slicers, no filters in our expression. So this is really total sales across all time. But once we start adding filters into this report, these numbers change dynamically, which is incredible. So let's do that. I am actually going to zoom back out, and on this table visual right here, we're going to go over to the sales territory table, and we are going to add in the sales territory country. And I'm going to drop that right here on the rows, and you'll notice immediately that all of my values are filtered down. And this is such an incredible feature, right? I worked in SQL for many years from a consulting capacity, building solutions for customers. And if they wanted total sales by country, I had to write them an expression that was total sales by country. And if they wanted total sales by country for 2005, I had to write that expression as well. But when you're in Power BI, we created one very simple calculation. And because of the relationships in the data model, it's automatically being filtered down, which is incredible. So we have that right there. And then if I go and say, you know what, I want to take this a step further. So I'm going to clean up the table a little bit. I'm going to get rid of everything except total sales. And I'll do that by going back over to the right here, just so we have more kind of landscape to work with. We'll get rid of transactions and cost and profit margin. And then on the columns, I want to add in the year. So we're going to add the calendar year into the column of this matrix. And I'll go over to my date table. We're going to grab the year column from right there, and we are going to drop that on the column section. And let's take a look at this expression again. So now we're looking at total sales, but this cell right here that we're looking at in this matrix, this represents the total sales for Australia for the year 2005. So it's being filtered down from the attribute or the column that's coming from our sales territory table based on that active relationship. And it's also being filtered down based on the year that's coming from the date table based on that active relationship. So one measure is going to work across all of these different descriptive attributes in our data model. The other way that you might slice this data is we might add a slicer across the top. Remember, any filters that are in this report are going to be part of that filter context, which is what we're talking about now. So we're going to add a slicer right here across the top. Let me make sure volume is there. There we go. And I'm going to add a new slicer. And for this slicer right here, let's see, we are going to bring in from our customer table, I'm going to bring in the customer breakdown, that calculated column that we created earlier. So in the customer table, let's go ahead and grab that age breakdown, and I'm just going to drop it right there in that slicer. If I did that too quickly, what I did is I grabbed this visual right here in the visualization pane. And then from the customer table, we grab the age breakdown. So this gives us another way, just a visual representation of kind of interacting with our data and filtering at the same time. And then we're not going to worry about formatting this or changing the slicer at all. And I'm going to go in here and say, you know what? I only want to see total sales for Australia for 2005 for the age demographic of 55 plus. So we'll click on the little checkbox right here, and that number has now changed. It's no longer 1.3 million. That filter context of that is, going to represent what? That is the total sales for Australia for 2005 by the order date, because our active relationship is actually on the order date, for age breakdown of 55 plus. Now we don't have any filters coming from the temperature table, so it's for all temperatures. We don't have any filters coming from the product table, so it's for all products. But that's our filter context that's being applied to that cell, and this is really, really awesome. So let me show you something else, another way that I like to think about calculated measures when I'm writing them, right? If we go back and look at total sales, and we look at this measure that we created right here earlier, you might read that measure as this is the sum of sales amount. I like to actually read that as something like this. This is the sum of sales amount within, right, within the current filter context. This is the sum of sales amount within the current filter context, meaning that this calculated measure that we developed is going to work within the filter context for whatever filters are being applied through the active relationships in the data model. Now I keep throwing that out there at you. We didn't actually build the data model today, but I keep saying active relationships, active relationships. Let me show you what happens when an active relationship doesn't exist. So right now, our table is being filtered down by 55 plus. And so let me hold it to 55 plus. You see that the value is 668,000 right here. If I go over to the model view and I actually delete, don't follow along with this part if you're following along, but if I actually get rid of that active relationship that exists between customer and internet sales, which is what allows those different columns from the customer table to automatically filter down internet sales, if I delete that relationship, it's not going to work. The filtering won't work anymore. So I'm going to right click, I'll delete that relationship right there. And by deleting that relationship, we go back over to the report view and we see it doesn't work. It's going to not allow us to filter it accordingly. So I think I deleted it. It's taken a really long time there. Well, I think we're frozen here. So we're almost near break. I think we're going to take a break in about 5 or so minutes, but I'm going to see if I can unfreeze this because it appears to be frozen. Hold on, let's see if we popped up on another screen here. Something going on in the background. Power BI desktop is freezing up. That is not what you want to happen in a live demo, but we can recover because it's right around break time anyway. So what we're going to do is I'm going to fix this while we take a 15-minute break. I'm also going to look over some of the questions that you guys had, see if there's any of those that I can answer as soon as we get back from break, which is a good time to kind of look at those and answer those questions. And so I'll see you back here in about 15 minutes. Thank you, everybody. And then we'll put a timer right here on the screen. And the timer is going to kind of come and go, but I'll make sure it's there as we come back to the class.
full screen with you.
All right.
3, 2, 1.
Hello and welcome back. Hopefully you enjoyed the first about hour and a half of this. We've already recovered from that. I spent the break, got all of our measures back into this working model. Just as a reminder, if you're enjoying what you're seeing here today, we have plenty of DAX boot camps that we do that are virtual events, 3-day events where you can kind of work with the data. There's some hands-on labs, ask questions, and really dive into the technology. And we also have a recorded platform as well. And there's 20% off of the on-demand learning if you choose to purchase that. So take a look in the description of this video if you're interested, and I'm sure you'll get an email from us afterwards reminding you about that as well. We had a couple of great questions. Now there have been thousands of questions it seems like, but a couple of great questions that I want to address real quick. One of them was, how can I get a count of number of transactions essentially for each customer? And it's a wonderful question because it takes us right back to what we were talking about right before we went on break, which is we can take advantage of filter context. We don't have to build any other measures than what we've already built. So let me show you how to return total transactions for each customer. I'm going to duplicate the current page that we're working in over here in Power BI Desktop. So we can just create a new page that shows the count per customer. And you'll notice that if I go over to my visualization and I get rid of, let's get rid of everything that's in this table. And I'm gonna add in total transactions, which is that kind of count star or count rows, count star in SQL, right? So we bring in total transactions. What does total transactions do? Got to think about that for a minute. Total transactions counts all the rows in the internet sales table within the filter context. That's why I love to always add that sentence to the end when you're not adding a filter yourself. So we have 60,398 total transactions, but you want to see those broken down by customer. Well, what we do is we go over to our customer table and we grab that full name that full name column that we created earlier. We drop it right there, and Aaron Adams has 4 transactions. Aaron Alexander has 1. Aaron Bryant has 5. So when we're looking at this in Power BI here, we're able to see those total transactions broken down by customer. And it's a beautiful thing, right? This is the wonderful thing. And I could tell by that question, that's a person that comes from a SQL background and you're used to having to write all these one-off calculations for every request. But in Power BI and DAX, you don't have to. You build that one calculation and you allow the filter context and those active relationships to do the filtering for you. We had another great question. Another question that we got was why should I use calculated columns versus calculated measures? Should I build the column in the model or should we build it more dynamic? Another great question. When you're building calculated columns and measures, if it's going to be an expression like total sales, total transactions, total profit, profit margin, any of those, you should build them as a measure. The reason you want to build them as a measure is because they're going to be dynamic. Just like we saw with total transactions here, it's always going to work within the filter context. If you build this total transactions on your customer table, then yeah, it'll work anytime you filter it by the individual customer, but it won't be dynamic when you filter it by the year or the country or the product. So that's another thing that you have to be careful of. When I'm building aggregations, kind of rule of thumb is I'm always going to do it in a calculated measure because it's dynamic. Somebody else asked, well, I don't have a table. I don't have a date table. How can I build a date table? Well, there's a couple methods, right? We could do it in the Power Query Editor. There's a great blog by Devin Knight on his devinknightsql.com that I always use to create a date table. But if we're talking DAX and you just want to create it right here in data analysis expressions, you can create a calculated table. Remember at the very beginning of this, we talked about with DAX, you can create calculated columns, calculated measures, and calculated tables. So one thing you can do is you would go up to the modeling ribbon here at the top, and then I would click on New Table. And when you click on New Table, you're saying, hey, I want to create a new calculated table in this data model. It can be a derivative of an existing table. It can be an aggregate of that table. It can be filtered down. What we're going to do, though, is we're going to create, let's just call it our calendar date table. And our calendar date table, the way you can create it is you can create it with one of 2 functions. You can either do it with calendar auto, or you can do it with just the calendar function. I prefer the calendar function because you tell it the start date, you tell it the end date. And so I would say calendar, and then remember, when you build that date table, it must have all range of dates and it must go back to the first day and the last day, right, of whatever year you go to. So if we were going back to January of 2005, I would say, or 2015, I would say 1/1/2015, and then I would pass in 12/31/2015 here, close that up, and this will give you a 1-column date table that just has the date. And then you would use calculated columns to create your month, your year, your quarter, so on and so forth in that date table. Now, this isn't necessarily the best method that you can use, but it does give you a quick and dirty date table so you can start building out kind of some proof of concepts. So let's hit enter real quick and we'll take a look at the results over on the data view just to make sure that's what you were looking for. Once again, what I recommend to most people is that your IT department probably has a great date table for your company, for your industry, that shows working days, that shows holidays, that shows a lot of really good stuff. So I would definitely reach out to the IT department and I would ask them specifically, hey, do you have a date table I can use? Because it's probably going to be great and you're going to be able to leverage that. But if you don't, you can absolutely do something like this. And if you email me, I can send you a reference to that Power Query blog that really sets you up with about 7 or 8 columns right off the bat. So where is the table we created? Here we go, calendar date table. And it's going to create for us a 1-column table that has every date that we're looking for. And then we would just build calculated columns on here, extract the month from that date, extract the year, so on and so forth. So that's how you do the date. Now, I think there was another question here around, what was it, around fiscal calendar?
Yes.
So if it's around fiscal date reason. So a lot of companies have fiscal dates, fiscal calendars that go from, like Microsoft goes from July 1st to June 30th. So that's really how they measure it, right? So if you do a year-to-date sales, you want to see from July 1st to June 30th. You don't want to start over when you hit December 31st, that calendar year. And so the great thing about time intelligence calculations, we haven't gotten there yet, but the great thing about them in DAX is that there's actually an optional parameter. Remember we talked about optional parameters just a moment ago with the divide function? We're going to take a look at those optional parameters with time intelligence functions as well. They're awesome. They make it so easy to write your code. And for those of you that are out there asking those SQL type questions, you're going to notice that it's really easy. And Brian is going to be putting in the chat window for you guys that blog I was referencing for Devin Knight. All right, so we've answered some questions. We're going to see if we have some more questions we can answer at the very end of this, but let's jump back into our discussion here with the DAX workshop, and we're going to continue talking about calculated measures and filter context, which is going to lead us right into our next topic, which is going to be calculate. All right, so right before we went on break, looking at my notes here, remember I was rebuilding that model, we're going to build a new measure here. Let me build the scenario. This is really cool. So if we go back over to page 1, in page 1, we were looking at our total sales by country. And so I'm going to go back over to this visual, get rid of the year. We've kind of gotten a feel for filter context right now and how awesome that is. But sometimes it works against you, right? Because sometimes you're like, okay, I want to be able to compare Australia to all sales so I can get a % of total. Now, maybe you've used show value as. I'm going to show you the difference between those as well in just a moment. And I'm going to show you why you might want to use this method or that method. But right now, let's look at this. If you wanted to get Australia's % of total, which would be their 9 million in sales divided by 29 million in sales across all of your countries, that's a little bit difficult when you first start with DAX, because what I want to do is I actually want to get this 29 million that's being represented right here. I want to kind of put that on the same row as Australia. So I want it to show me my total sales right here of that 29 million. And I want that to show up all the way down, because once I can get that number, the rest of that % of total calculation is really easy. It's just a basic arithmetic operation, right? So what I'm going to do here is we're going to create a new calculated measure that's going to return total sales for all countries. And we're going to look at a couple of different ways of building that calculation when you're working in DAX. So just like before, I'm going to go over to my internet sales table here. I'll right click on the table, and then I'm going to go ahead and select new measure. And that's going to create for us a new calculated measure right here in Power BI. And this is going to be called, and I'll just call this something like total sales and be all explicit, all countries, right? So we're returning total sales for all countries, and then we'll hit equals. Now, like I said before, calculate is the most powerful function in all of DAX, and you're going to probably wind up catching yourself using calculate in about 80% of all of the measures that you create, because those base measures that we created right before break, they just work. They work all the time. So when you want to kind of create a derivative of that or a variation of that, we use calculate to evaluate that expression within a new filter context, a modified filter context. So in this one, I'm going to write a sentence over here in the comments of what I'm trying to achieve. This always helps me out. I want to return the total sales for all countries, right? So I'll just keep it in all caps to keep it consistent now. I want to return the total sales for all countries. So since I'm going to be modifying the filter context, I know I'm going to be using calculate. So I'll start with that, and then I'll do shift enter to go down to the next line. Now, I should have left that IntelliSense up since it's the first time we're looking at it. When you're working in calculate, the first parameter is always your expression. For me, that's always an aggregation that I've already built. So it might be my total sales measure, my total cost measure, my year-to-date measure, my profit measure, but I'm reusing a measure I've already created. So in this situation, I'm going to return total sales. And now we have to apply the filter. This is where our filter kind of takes priority over those other filters that are in the filter context here, because we're modifying that filter. So we're going to tell it that, hey, we want to return total sales for all countries. So we're going to use a function here called all. And what all does is it returns all the rows in a table or all the values in a column. And the key word there is at the very end, ignoring any filters that may have been applied. So I'm going to use all, and then I'm going to tell it to ignore all filters that are coming from the sales territory table, and more specifically, the sales territory country. So we'll close that up with one closing parenthesis, and we'll close it with another. And so if you read this, return total sales for all countries. We're removing those filters. There is another way to write this that I find some people like a little bit better, so we'll show you that method here in just a moment. So I'm going to hit enter, and when I hit enter, that's going to complete the DAX formula, and then up here at the top, I'll click on the currency, English United States, and then we're going to come over here, we're going to grab that measure, let's throw it in our table and take a look at what that looks like. All right. So this is awesome. This is what we wanted. Evaluate total sales within a modified filter context, which is ignoring the filter coming from country. So now we're seeing 29 million in sales represented all the way down. Now there's a little bit of weird behavior that just showed up here, a little bit of odd behavior. We get this record that was previously not showing up under NA. Before it wasn't there, but now it is. So the default behavior of a visual in Power BI is very similar to like a default behavior of a Power Pivot or a pivot table in Excel. The default behavior here is that whenever all of the values for a row are blank, the tables in your tables and your charts in Power BI will automatically hide those members of a column. So NA is a member of the country column. It was being hidden automatically. Now it's not, because total sales all countries says, okay, the filter is NA, ignore that filter and return total sales for all countries. So how do you work around this, right? I don't want that NA to show up. How can we fix that? Well, we can do this with some really basic, really simple conditional logic. We're just going to use the if statement. So let's modify this measure real quick to kind of satisfy this scenario. So if we go back up to the top here, we're going to create some conditional logic that says, look, if total sales is blank within the filter context, then also return blank for total sales all countries. So we're going to say if, and then our logical expression is going to be total sales. Actually, there's a couple ways to write this, but I'm going to use is blank. So if is blank total sales. And what this does is it's a Boolean expression. Is blank is going to check total sales to see if the value is blank. There's no value. And if that evaluates to true, then we're going to do the next expression for if. So if that's true, it is blank, we're going to also return blank for this measure that we're creating. If it's false, meaning that total sales had a value, then we're going to perform this other calculation here. So let me just select all of this and tab that over. We need to add another closing parenthesis here at the end. So if total sales is blank, return blank for total sales all countries, else return total sales for all countries, right? If there was a value for total sales, then let's return total sales for all countries. And this is a pretty common pattern that you can use in DAX to get rid of those blanks. In this example, we had one member of the country table in A that was showing up. But what if you were looking at a customer table and all of a sudden you had thousands of records that were showing up? That would be a really bad visual. So this is a way to kind of clean that up very simply in your DAX. So we're going to go ahead and hit enter here, and you're going to see that row goes away immediately. All right. So I told you a moment ago there's another way we can write this expression. Some people find all a little bit hard to comprehend. I use all the time because I always have, but there's actually a newer function we can use and we can leverage here called remove filters. So instead of using all right here, you could say calculate total sales and remove all the filters that are coming from this column. So what I could have done instead is I could have used a function called remove filters, and it clears all the filters from the specified tables or columns. So the same exact results that we get with the all function, it just might make more sense to you. And if it makes more sense to you, then go with that, right? Use what is the easiest for you to understand and remember going forward. So we're going to say remove filters. We're going to go to the end. We're going to hit enter. we get the same results. So I hit enter, it's refreshed, the results are the same. All right, now we're gonna build a percent of total calculation. We're gonna build a percent of total calculation because now we have everything we need. Percent of total is really easy. It's divide total sales by total sales all countries. And then we're also going to take a look at another example here that's not just the percent of total that we built, but it's the built-in percent of grand total. And I'm going to show you the difference between the two. So let's do this real quick. We're going to build a percent of total calculation. And we'll go over to our internet sales table, right click, and create a new measure. And so we'll call this one percent of total. And our percent of total is simply going to be total sales divided by total sales for all countries. So we'll use, of course, the divide function. Anytime I use divide, I'm always going to kind of use that divide function instead of the divide by operator. And so we're going to say divide total sales by total sales all countries, like so. And that's going to give us our percent of total. Now I'll hit enter here, and when I hit enter, we'll wait for that to complete working. And then I want to set this up as a percentage. So I'll click right there on percentage, and then we can add that to our table and make sure and validate that the results are working correctly. So let's go ahead and do that real quick, like so. And you'll see that when we're looking at Australia, Australia had 9 million in sales. Total for all countries was 29 million in sales, which means that Australia is about 31% of all sales across all countries. If I sort this by percent of total right here at the top, we can see that United States was 9.3 million. They're around 32%. United Kingdom is around 11.5%. And so this is how we can use calculated measures to be able to kind of develop those ratios and those percentages here. The hardest part of this calculation is understanding how to use calculate to ignore the filter that's coming from country. So once we return total sales for all countries, the next part here, that percent of total, is really easy because it's just a basic divide by operation. Now, some of you have been working with Power BI for a while and not DAX, and you've figured out other ways of doing things. And you've figured out, wait a minute, I've seen this before by simply just doing a percent of grand total on a column by clicking a button. So let's take a look at that. It's going to look the same at first, but then you're going to notice it's actually a little bit different. And both are good solutions. It just depends on what you want to do yourself. So over here, I'm going to add another measure to this table. I'm going to go grab the total sales measure and drop it in the table right here, right? So I'm going to drop it in the table here. Now you say, I want to know the percent of grand total for total sales across all countries. Well, what we can do is under the value section right here, you'll notice that we have total sales. If I click the little caret looking symbol, this little drop down symbol for total sales right there, we'll see that we can do something called show value as. And one of those options is show value as the percent of grand total. And this works great if you just need a quick and simple selection here. So I'm going to say show value as the percent of grand total. And then you notice that immediately total sales has become the percent of grand total. And it works, and we didn't have to write all those expressions. So obviously the natural question, or the next question, should be, well, why did we build that measure? Well, the measure kind of gives us more flexibility. We can force it to do very certain things. This is not the same calculation. What percent of grand total sales does, it says show the percentage of grand total for what's inside of this table. Percent of total, remember, we ignored all filters coming from country. So let me show you what I mean by that. We're going to add a slicer here so you can see the difference between these two. So over in the visualization pane, I'm going to click right here to add a new slicer to my report. And then in this report, in this slicer here, I am actually going to add all of our countries to this slicer. So over on our sales territory table, I will grab sales territory country. We'll drop that right there in the field list. And then we have all of our countries. Now, normally I would format this, make this look a lot better, make it look like a slicer in Excel, but we're talking about DAX, so we won't worry too much about that. Let me go ahead and just move it over to the left or over to the right a little bit. Here we go. And so when I go ahead and grab or start filtering this down by the slicer, you're going to see the difference, right? So I'm going to click on Australia, Canada, and France. So you notice that our percentages of totals are different. This value right here of 66%, that is saying that Australia, which is the one that's in the very first row, Australia is 66% of the countries that are represented in this table that have been filtered down by the slicer. However, the percent of total that we built a moment ago is ignoring the fact that there's any filters coming from the country anywhere, right? It removes all filters, whether it's coming from a slicer, filter pane or the rows or the columns on a table. That's why we built that the way we did. And so this still gives you that original value saying, look, Australia is 31% total sales across all of your countries in your data model. That's what that is returning for us. So there's a difference here. Now, I'm not saying one's better than the other. They're both great. Just depends on what your business requirement is. You might say, look, when my users come in Power BI and they start filtering it down to certain salespeople, certain customers, certain products, I want the grand total to reflect that, to only that selection. Well, then percent of grand total is perfect for you. I still wouldn't use percent of grand total. I'd use another way of writing this calculation using a function called all selected. We won't actually cover all selected today unless we have a little bit of time there at the very end of the day. Maybe we could go back and revisit this, but this gives you exactly what you want. And so that's the difference between those two. And that is our percent of total. All right, so with that being done, we want to take a look at a couple of other examples here. And we're going to keep using calculate to evaluate an expression within a modified context. So that was our all countries removed. We removed some blanks, percent of total. All right. So let me clean up this table just real quick here. I'm going to remove all of the filters from our slicer here at the top, and I'm going to remove a couple of measures. What we want to do in the table now is I want to show you how we can bring in things like total sales for United States, total sales for Canada, and we can see them side by side one another in the same table. And so that's what we're going to take a look at right now. So let's go ahead and clean up this table. I'm going to get rid of percent of grand total here. I will also go ahead and get rid of percent of all totals, or total sales for all countries. And we're going to build two new measures here. The first one is going to be total sales for the United States. And I also want to duplicate this report page because I want to see this by year, and you'll see why. So I'm going to duplicate this report page by right-clicking on the page there at the very bottom and then doing duplicate. So I have this new page. I'm going to replace the country here with year, so that you can see kind of the analytical value of doing this. Whoops, let's open back up. There we go. And so from the date table, I'm gonna grab the year and drop that right on the rows here. And so now I'm looking at my total sales by year. All right, so we got total sales by year here. And I wanna be able to see something. Let me get rid of that slicer, whoops. I wanna be able to see total sales for the United States for 2005, total sales for Australia. I wanna be able to see them side by side with one another. I am going to go ahead and click on that little save button right there because it's already crashed on me once. We don't want that to happen again. All right, and then we're going to go ahead and create a new measure. So on the internet sales table, we're going to create a new calculated measure. And this is where we're going to be much more explicit. And we're going to say, look, evaluate total sales for United States. Regardless of what filters are there, if the filter is Australia, override that filter with United States. If the filter is all countries, override it with the United States. So how do we do that? We're going to do total sales equals, well, let's name this United States. And then that equals, and we're going to use calculate because we're modifying the filter context. We're going to return, so calculate total sales, right? So that's the first part. Calculate expression. You're going to get used to this. This is a very common pattern you use all the time. Calculate this measure within this modified filter context. So the filter that I want to add here is going to be where the sales territory country is equal to United States. So we're very explicitly saying only return the total sales for the country United States. That's what we're doing here in this example. And so we'll hit enter. And then we're going to take a look at it right next to that original total sales measure. That original total sales measure is the sum of sales amount within the filter context, respecting all filters. This measure here is kind of a modified filter context. It's changing the filter context for us so we can get exactly what we want for those very specific use cases. So we'll format it real quick, and then I'm going to drop that right here in the table. And now we get to see it side by side. Here's our total sales for all countries. Here's our total sales for United States, broken down by year. And you could do some type of percentage of, all countries compared to United States here. We can also do another measure, right? We could do total sales for Australia, total sales for France. And so we're going to do that. We're going to create one for Canada. Like I said, we're going to walk through quite a few examples. Then we're going to do some conditional logic in here as well. So let's create another example very similar to the one we just did. Right click on internet sales. And we're going to create a new measure. And this is going to be called total sales for, I don't know, let's go with Canada, right? I can spell Canada. That's a good one. I always struggle with Australia. I always want to add an extra I in there. I don't know why. So we're going to say calculate total sales. And this time, instead of calculating total sales for United States, the modified filter context is going to be for Australia. So we're going to say calculate total sales for where the country, so sales territory table, and the country is equal, oh, that did not do what I wanted it to do, where the country, do that one more time, there we go, equals, and we're going to go with Canada. All right, so we'll close that up and then close up the calculate statement. And this is very similar to what we did with the United States. In fact, like I said, it's a pattern. Calculate my expression. Now I define my filter context. We're going to go ahead and give this a currency of English United States, add it to the table, and then we can see those two side by side right there in our table. So let's go ahead and grab Canada, drop it right there in that table. And this is really cool, right? You're able to see total sales for all countries because that's within the filter context. Total sales for United States, total sales for Canada. Now, what happens when we go up to the slicer and I click on France? Well, total sales is within the filter context, so that becomes total sales for the country France. How do the other two change? Well, let's take a look. If I click on France, United States didn't change, Canada didn't change, but now this technically represents total sales for France because it's respecting that filter. Understanding filter context in DAX makes your life really easy because a lot of those questions, like the one we got right after break, seeing the total transactions broken down by customer, that pops right up. It works because the filter context is doing the work for us. And so that's an awesome thing. So this is how we use this. Now I did want to show you some conditional logic kind of within calculate here. And I want to show you how do we get maybe total sales if the country is United States or Canada. And there's a couple of different ways to write that. And I want to show you that logic here. So let's do that next. That'll be the next thing we do. So I'm going to build a new calculated measure, kind of just working along. We're just writing DAX now. Right? We're just writing DAX, getting used to this pattern because once again, this is a very common pattern that you'll write a lot of times in DAX. And the new measure we're going to create is going to be, let's call it total sales, and it's going to be US and Canada. And this time we're going to say calculate total sales, right? So return total sales for when the country is United States or Canada. There's a couple of different ways to write this. The first way you could write this is we could just use the double pipe delimiter, which is an or condition. So I could say where the sales territory country is equal to, let's say, United States, right? So that would be our first kind of shot at this. And then I could use the double pipe delimiter to say or. And we would say or the sales territory country is equal to Canada. So we don't want to use and here because that would mean it has to be United States and Canada at the same time. That's an intersection. That wouldn't work. But if it's Canada or United States, return the total sales if it's either one of those countries. So that'll be a larger number. And so this is a combination of that. Maybe we're trying to build a North America versus all other groups, right? This is how you might approach that. So this is going to return that for us. Now, the only problem with this method that we're doing is that it's a little bit harder to manage because you have to keep adding rows and subtracting rows whenever you add countries or subtract countries. So that's one thing to consider when you're working with this example right here. But I'm going to go ahead and format that one as English United States as well. And then we'll put that in our table also. So that's going to bring in our total sales for US and Canada. And of course, if we add these two together right here, that is in fact 1.247. So just a really easy and quick way to validate that the code that we did is correct. Once again, it is also ignoring or overriding rather that filter that's coming from the slicer that says France. All right, so I want to take another look at another way of writing this calculation right here real quick, just so you can see there are multiple methods. Another method you might do is you might use the OR function. Again, I'm not a very big fan of the OR function because it's similar to what we just did where you have to write it all out, but the OR function actually only takes in two parameters. So if I use the OR function here, it takes in two parameters. Both of those have to be logical. So expressions that evaluate to true or false. The first expression would be if the sales territory country is equal to United States, if that's true. And then we separate the two conditions with a comma, and then you have the second logical expression. The biggest limitation here, though, is that the OR function only takes two parameters. So if you have 3 or 4 or 5 different countries you wanted to group into this, you'd have to keep nesting those multiple OR conditions, which I don't very much like, right? But this would work. If we hit, close up the parenthesis here, we hit enter, over here you see we get the exact same results. So it works great. It's just not my go-to. So what is my go-to? Well, I come from a SQL Server background, writing code in SQL Server. I like the in clause, right? And so DAX has something very similar to the in clause, and it makes the code easier to read and I think easier to manage. So that's what we're going to do here. When the country is in, and then we provide a list of countries that we want it to return. So instead of using or, we're going to get rid of that. And I'm going to delete everything on the bottom here and go all the way back up to the top here. So we're just cleaning it up. And we're going to say when the sales territory country is equal to, nope, when the sales territory country is in. So we're going to provide a list here. We're going to say when the sales territory country is in, we're going to do curly bracket, so when it's in this list. And then we're going to say comma, and then Canada, and then curly bracket, and then we'll do one closing parenthesis to close out that calculate. And so to me, this is just a lot easier to manage, a lot easier to maintain. If I want to add countries, comma, add the country. You want to remove a country, you just remove it from that list. So this right here will give us the exact same results. 3 different ways, the exact same results. We'll hit enter again, and you'll notice that the results are still the same. All right, so that was total sales for US and Canada. Now there is other ways of kind of looking at this, right? One of the things you might have noticed a moment ago when we were looking at the total sales for all countries is that that was working really well. Let's add that back in, just like so, and let's add in the percent of total as well. So I'm back on that first report page, and I want to talk a little bit more about calculate and how you can add more than one filter into a calculate expression. So we have a slicer here. Let's change this slicer to maybe the date instead of country. So I'll add the year in here real quick so you can see this. One mistake that a lot of people make when they're working with calculate and they're ignoring filters like we did with the all function, or they're using remove filters, is they think that that applies to all tables and all columns, but it doesn't. It actually applies only to what you specify. So if we add a filter in here on our years on the slicer, and you come over here and you click on something like, let's say 2006, how does this value change? Does it ignore that year filter or does it respect it? Well, if you remember, let's take a look at total sales all countries just to make sure we're all on the same page. Total sales all countries is simply saying calculate total sales and remove filters from sales territory country. We're not saying remove filters from the year, from the date table, or remove filters from the product table or any other table, right? We're just ignoring filters from the country table. So therefore, if I come over here and click on 2005, you'll notice that this changes accordingly. So now I'm going to be looking at total sales for all countries within the filter context, irrespective of country, because we're ignoring that, of course. And this is exactly what I want in this scenario. This is perfect because if I filter it to 2005, I can see that Australia was 40% of our total country sales across all countries in 2005. But if we go take a look at 2008, Australia was actually only 26%. So they fell from 40 to 26%. Now that might mean that Australia started doing worse, or it might mean we just really built up a lot of those other markets and they're more competitive. But either way, it's important to understand that calculate only, you can add, it doesn't ignore everything when we do what we did. Now, I do want to show you this though. You could be in a situation where you're like, okay, well, I want to ignore all filters coming from the date as well. Well, you could add additional filters into calculate. So if I hit comma right here and I hit shift enter, you'll notice that calculate says, okay, you can add another filter. And then we got a ... here that says you can add additional filters after that. So I could go in here and I could actually say, I want to ignore all of the dates coming from the date table. I want to ignore the years. Or you could even say, I want to return total sales all countries for the year 2008. And you could do any of those. How would we do that? Let's take a quick look. And hopefully this is review. What I might do is something like this, or we might say remove filters, just like we did before, from the date table. That would ignore all filters that are coming from the date table. So now it would ignore the filters on the slicer if you wanted to do that. You could also do something like date, calendar year. Oh, we don't have calendar year, we just have year, equals 2008. And so this will always return total sales for all countries. Now, I don't know why you would want to do that in this situation. I'm just showing you and introducing you to the concept that you can add multiple filters within Calculate if you do want to be more explicit and more specific with the way that you change that filtering, which I've definitely done. I've done this many, many times when I'm writing DAX. This is not a great example for that. All right, so we've taken a pretty pretty long look here at calculate, and we're nowhere near done. We still have a solid hour ahead of us, and I have a lot more calculations I want to show you. So the next thing that we're going to take a look at here, and I'm way behind on my notes because I kind of know what demos we're going to do, is we're going to take a look at 2 more examples of calculate, and then we're going to jump into time series analysis, which I'm excited about. So if you wanted to see total sales for only the year 2007, that's going to be something very simple. It's calculate total sales where the year equals 2007. So we'll go over to our internet sales table, right click, create a new measure, and I'll show you this one, and then we'll move on to time series analysis as soon as we get done with this. Total sales for 2007, right? So we're going to return the total sales within a new modified kind of filter context, which is only for the year 2007. So we know we're changing the filter context. We're going to use calculate, the most important function in all of DAX, and we're going to say return total sales for, what was it, 2007, right? So date year equals 2007. And that right there is going to say, look, whatever filter is coming from the date table, whatever the year is, always return it for just the year 2007. And we would, of course, go ahead and format this very quickly as English currency United States. And let's go ahead and drop that in our table. Yeah, we can see it right here, right? So let's get rid of a couple of things so we can just look at it. And you'll notice, obviously, the difference, you'll notice there's a very clear difference between total sales, which is within the filter context. So right now it's for all years because there's no filters coming from the year, and total sales for 2007, which is filtering this down specifically to the year for 2007. In fact, if I click on 2007 in the slicer right here, you'll see that they now are exactly the same because now this measure is also returning total sales for the year 2007. So that's just another example real quick of calculate, but we're not done with calculate. There's definitely more we want to talk about with that. Let's jump into now time series analysis. How do we get year-to-date sales? How do we get fiscal year-to-date sales, year-over-year sales? All of those are, it's probably some of the most powerful things you can do in DAX because of how simplistic it is and how simple it is. Remember, there's requirements we talked about in the PowerPoint, which is you must have a date table, make sure your date table has all possible dates, and then make sure you don't have any gaps in your date table. All right, let's jump in and take a look at time series analysis. In this example, the first thing we're going to build is probably one of the most common, and that's going to be our year-to-date sales. If it's October 8th, and we want to see all of the sales from January 1st through October 8th so we can kind of get that trend, then we can do that very easily here by just returning the year-to-date sales. So over on the internet sales table, I'm going to right-click on internet sales and create a new measure. And this measure is going to be our year-to-date sales. And our year-to-date sales is going to equal all of the sales to the current date. So we're going to use a function in DAX called total YTD. And it's a super easy function to use. First of all, we're going to pass in our expression. That expression actually should look familiar because it's the same thing that calculate asks for, which is an aggregation. So if I wanted to get year-to-date profit, I would provide my profit measure. If I wanted year-to-date profit margin, that'd be kind of an odd one. Year-to-date total transactions, we would provide our measure for total transactions. What I'm going to do here, though, is I'm going to provide total sales because that's what we're looking at. So we'll type in total sales, and then we need to now provide another parameter. The parameter that we see right there is going to say dates. About 90% of the time when you see dates right there, it's asking for the date column from your date table. All right. There are some exceptions to that. Sometimes we'll manipulate that first, but normally that's what it means and that's what it's asking for. So I'm going to pass in the date column from my date table here, like so. I'm going to close up the parenthesis, and that's it. We just created an incredible year-to-date sales calculation that works across all of the dimensions in our data model. It works by country, by year, whatever you want to filter it by, it will work. And we did it with literally, technically 5 words of code. This is awesome. So we're going to hit enter, and then we're going to go over here and we're going to change the currency. And we're going to take a look at what this looks like. We're going to validate it's working, and then we're going to go take a look at the fiscal, because I know there was a lot of questions around kind of the fiscal year-to-date as well. So we'll change this over to United States, English currency. And then let's go over to our table where we already have the year. I'll clean that up a little bit, get rid of a couple things. And I am going to bring in the year-to-date sales calculation right there. And let's get rid of the France filter. All right. In fact, I'm going to get rid of United States. And so what we see right here at the year level is we get the exact same number for total sales that we get for year-to-date sales. And that's because they're both doing the same thing effectively. Total sales has sum up all of the sales for this filter, which is 2005. Year-to-date sales says filter everything from the beginning of this until the end of this period, which is January 1st to 2005, December 31st. However, if we really want to see the value here, what we will do is we'll bring in the quarter or the month. Let's add that to our table so we can kind of see this working in action. So I'm going to add in the calendar quarter over here, and then I'm going to go grab the English month name, like so. All right, and now in my matrix, if you're new to Power BI or you haven't worked with visuals a lot, I'm going to click on the drill down here at the very top right to drill down to the quarter level. And this is where we can first start seeing this functionality, right? So for example, in our year-to-date sales right here, if you look at the fourth quarter, Q4, which is all the way to December 31st, is going to be everything for this year up until this date. So that is actually the cumulative total for everything this year, which we started in July. So July through December. Now, you'll notice that as soon as we get down here in blue, we get to January, that number starts over. So it doesn't go 3.2 million plus 1.7, which is like, 4.9. It actually starts over at 1.7. So the first quarter equals the first quarter. But then, if we get out of all that real quick and we go down to the second quarter or the third quarter right here, like Q2, you'll see that that is, again, going to be the cumulative total for the first quarter and then the second quarter. And then you keep going down. Now, the great thing about this calculation is that this works at the quarter level, the month level, and the day level. So if you keep filtering this down even further, like this right here where we expand down one in the hierarchy, you'll see even at the month level, it's slowly accumulating. And if you go down to the day level, it works. This is just a very simple, very easy calculation that's very dynamic and comes with a lot of capability. All right, so we have a question here. Does DAX, and let's see if I can understand the question. Does DAX have the ability to do this analysis by week? It does, but not through a very simple time intelligence calculation. So if you're doing this kind of week over week calculation, that means that you're probably working in a custom calendar like a 544 or a 445. And so you can still build that out pretty easily in DAX, but your date table has to be set up a very specific way with certain flag columns. And then what we would do is we'd say calculate total sales. And then in that modified filter, we would probably use something like the filter function to redefine what the previous period is. So if I'm at the week level, go back and grab the last period, grab the last week. So there's not an easy way to do week over week inside of DAX, unfortunately, but it's not very difficult either. If you're familiar with calculate and how to evaluate something within a filter context or a modified filter context, you can definitely do that. Usually what you want to do though is you want to build your date table out to have all of those attributes, and that makes the DAX a lot easier to do. So great question. There's just not a really easy way to do that one. Not as easy as this anyway, because this is really easy. We get spoiled with DAX because a lot of stuff we do in DAX is really easy to do. And so that's a little bit more complicated, a little bit more code, a little bit more validation, but definitely possible with a limited amount of time. All right, let's take a look at year-to-date sales for the fiscal calendar. I know we got a ton of questions on that, and this is a fan favorite. People always love this. So we're going to take and actually let's just create a new calculated measure so we can see these side by side. And this is going to be our fiscal year-to-date sales. And for this one, we're still going to use our total sales, right? So we'll do total YTD, like so. Our expression is going to be our total sales. And then we're going to pass in the date just like we did before. All right. Now you're going to notice that we have two optional parameters for this total YTD expression. The first one is filter. I get a lot of questions about that. I don't often give demos, but I think I might do one real quick here for you guys. The other optional parameter is year-end date. The year-end date is really what we're focused on right now. So the year-end date here would be, let's say your fiscal year-end ends on June 30th. Well, we would go in here and we would type in, my year-end for my company ends on 0630, like so. And now it doesn't start over when it hits December 31st. It keeps going and going until it hits June 30th, and then it starts over. So if you have a fiscal year that ends every year on March 31st, June 30th, September 30th, you just put it right there, and it'll automatically handle that for you. Once again, really awesome capability in Power BI and specifically in the DAX language. So we're going to hit enter here and then we'll format it and then we'll throw that in our chart and we'll look at it side by side with year-to-date sales. So don't take my word for it. We're going to validate that this is working exactly the way that we want. So we'll drop it right there. And if we look at this, right, what fiscal year-to-date sales is going to do is it's going to go from July all the way to December, just like our original year-to-date calculation. So at December, they're the same. But that original year-to-date starts over once it gets to January because it ends on December 31st. Our fiscal year-to-date, though, keeps going, right? So you see that this cumulative total that we're looking at, this 3.863 million, that is the total for all of the total sales starting from January of this year all the way back through last year, right? All the way back through July 1st of last year. So July 1st of 2005 all the way through June 30th. And so to verify that, let's go all the way down to June and watch this start over. So we have January, February, and March. Then we see April, May, and June. And now it starts over because we specified that our year-end date is June 30th. So when it gets to January, it starts over. That's how easy it is to do a fiscal year calendar right here for year-to-date sales in Power BI. All right, so that's the first example, year-to-date sales. I did tell you I was going to throw a little bit extra out there at you, that other optional parameter. So when we're working in total YTD, there were two optional parameters. The first one was filter. What does that mean? Well, total YTD is actually a derivative of calculate that the Microsoft Power BI team just made easier for us. So technically, we could do what we just did with total YTD by saying calculate total sales, and then we would define the filter for the beginning of this year through the end of the current filter context. And you could add additional filters in there, right? So you could do other filters. Total YTD allows us to add those additional filters. So let's say you wanted year-to-date sales for only the weekday. All right, so only the weekday. I don't care about weekend sales. I work Monday through Friday. I only care about sales during the weekday. All right, that's a great scenario. So let's take a look at that. We're going to add another optional parameter here to our year-to-date sales. So we'll go back to the original calculation. And we're going to add in that filter right here. So this is actually going to be our year-to-date sales based on the weekday. And I'm going to add in a filter that says where the date and then the day number of week. Unfortunately, we don't have a flag that is just weekday versus weekend, but we can use the day number of week here. So where the day number of week, and we're going to use in, and I'm going to use a curly bracket here, and we'll just say 2, 3, 4, 5, and 6. So if it's Monday, Tuesday, Wednesday, Thursday, or Friday, which is 2, 3, 4, 5, and 6, we want to return the total sales. If it's 1, which was Sunday, or 7, which was Saturday, we don't. Now, I just know that because I know this data. You would know your data in your date table. And I did it where I specified it because you could do a not in as well, but not in is a little bit trickier. You got to add not to the outside here. So I just kept it super easy for this example. So we're now going to return year-to-date sales for weekday sales. This is pretty cool. So notice that for 2005, it's 3.2 million, right? That's going to change. So we hit enter here. And since we just overrode the expression we have, it's no longer 3.2 million, it's 2.3. And all of these numbers are less. Remember, before, this was kind of mirroring this total sales right here, but it's actually 329,000. I want to do an entire YouTube series on optional parameters in DAX because there's so much capability there and people just kind of ignore them or override them because they don't understand how they work. It's a really good, I think it's a good series. I'm thinking about it. All right, so that is year-to-date sales. Now we're going to go take a look at another very common problem in DAX. I want to be able to compare this year to last year. You're about to see a very common, very popular pattern. And that is going to be using calculate as well. So we're going to build a new measure on the internet sales table. And this measure will be prior year sales. And what we're doing in this example is, once again, we're going to use calculate. And we're going to say, all right, take whatever the current filter is, whatever that is. So July of 2005, and go back to last year and get July of 2004. If we're at quarter 1 of 2005, go back to last year and get quarter 1 of 2004. Very common pattern. So we're going to say calculate our total sales within this new modified context. And the modified filter that we're providing is taking the existing filter and then going back 1 year. So we're going to use same period last year. And then you see we have that requirement for the parameter there that says dates. So we're going to grab the date column from the date table. So I'll do Shift Enter, and let me get rid of that IntelliSense, and we'll say date column from the date table. I'll give 1 and then 2 closing parentheses. Now let me say this again. This is a pattern. DAX has a lot of patterns that emerge. They're like you write the same expression over and over, you just replace one piece. So for example, if I wanted prior year profit, I just replace this expression with profit. If I wanted prior year profit margin, I just replace that with profit margin. Very common pattern that we're talking about here. So we're going to hit enter. I'll format that very quickly as English Currency United States. And this is going to work. It's going to give us exactly what we want. So let's get rid of fiscal year to date and year to date so we can just evaluate the expression that we created. And when we come over here, we get a bunch of blanks. Like, what's going on? Why are we getting a bunch of blanks? Well, we're getting a bunch of blanks because, quite frankly, there was no sales for July of 2004. We just started opening our business in July of 2005. So if we want to see prior year sales, we have to go to July of 2006. So let's go and take a look at that real quick. I'm going to make this a little bit bigger. And if we go down to July of 2006, it shows us right here that this is our current year sales. This is our total sales within the current filter context. And this is our total sales for the prior year, right? So if we go back and validate this, we will see that July of 2005 was 473,000. So this calculation is beautiful. And the great thing about it is you notice even at the quarter level, it works at the quarter level. So let's go look at Q3 of 2005 and see if it was 1.4 million. We go up. Q3, 1.4 million. So once you have your prior year sales, you can build a year over year calculation. It's super easy. It's total sales minus prior year sales divided by, I think, prior year sales if you want to do percentage growth. I always get that one wrong. Maybe it's total sales minus prior year divided by total sales from this year. I don't know. But the point is the hard part is getting the prior year sales, which really wasn't that hard. We just had to use calculate to know what the filter context was and modify it ever so slightly. So that right there is our year over year sales. Let me take a quick look at the note, make sure I didn't skip anything here. And it looks pretty good. It looks pretty good. All right. So I told you this was a pattern. So I'm going to go a little bit off script here. I'm going to add another expression here. You guys can kind of go back and look at the notes later and write this yourself. But what if I wanted prior year, year to date sales? So right now we have a measure called year to date sales. I want prior year, year-to-date sales. Well, you could go about this the really long way where you pull out your year-to-date, then you calculate it, then you go back. But remember, when you're using calculate with same period last year, this is a pattern that emerges that we can reuse over and over again. So this is a lot easier. In every DAX bootcamp that I do, I always ask this question. I never get this answer because we're always overcomplicating things, right? So if I go click on internet sales and I create a new measure here, we are going to create a measure that's called prior year, year-to-date sales. So that way I can see year-to-date sales for this year versus year-to-date sales for last year. You might look at it in a table, you might see it on a chart, like a graph where you can see them kind of intersecting each other and crossing over. So on October 8th of 2020, so far for the year, all of the days up until October 8th, am I doing better or am I doing worse than I was last year? It's a great trend. So we're going to say equals, and I'm going to do calculate here, and then total sales. Nope, not total sales because we're doing year-to-date sales. Year-to-date sales, same period last year. Now, some of you might be thinking, Mitchell, why aren't you using previous year? Well, previous year is different. It's not as dynamic as same period last year. It doesn't work at every period level. Same period last year is derived from date add. Previous period comes from parallel period, and parallel period works differently. So unfortunately, we don't have time to get into that in the demo today. But if you were writing this out and you tried previous year instead of same period last year, and you drill down to the quarter, the month, and the day, you would get different results. And that's because of the way that they work. They're different. Both of them have great use cases, and I use both of them. In fact, we're going to use parallel period here in just a few minutes when we get into semi-additive measures. So let's finish up this example and keep moving along. So same period last year. It wants the dates, which means the date column from my date table. I'll give that a couple of closing parentheses, hit enter, and then we'll format that real quick here as English United States. And now we have our year-to-date sales for the prior year. Of course, we would want to be able to look at year-to-date versus prior year year-to-date, which we could do. So let's go ahead and get rid of prior year sales here from this table. And then we are going to add in year-to-date sales and then prior year-to-date sales right there and right there. All right. Just like before with prior year sales, we get a bunch of blanks at first because there were no sales for that prior year. But as soon as we get into July, we start to see, okay, this year so far we have 3.1 million in sales. Last year we only had 329,000. Pretty good. Of course, we know we have 6 more months for 2006 that we didn't have prior year. But as you go down, you see that that total keeps to accumulating, and it starts over. So we start over in 2007. Now let's look at these two, because this is going to be pretty good. So year-to-date sales starting in 2007 is 342,000. If you look at January from the previous year, that cumulative total was actually more. So this year we didn't do so good. If you look at February, our cumulative total is added up to 668,000, but the prior year we had gotten up to 802,000. So we're about 140,000 behind schedule right now. So it's a really good way of analyzing your data and saying, okay, we got to put some controls and processes in place, change our marketing strategy. We got to up those sales if we want to get back on track for the year and make our goal. So prior year, very common pattern, calculate whatever the measure is, same period last year. You'll do that over and over again, very common pattern in DAX. All right, so now I want to take a look at semi-additive measures. Remember we talked about this in the PowerPoint, right? A semi-additive measure is something like an inventory balance, something like my account balance, which sadly is around $100. Please feel free to send an email to Devin Knight and tell him I need a raise. But those are going to be semi-additive measures, and you can't add them up across time. You add those up across dimensions. So you can add them up across some dimensions, but not all. Generally, it's across the time dimension where you can't add it, because if I had $100 on each day of the month and you're on the last day of the month, you can't say I have $3,000. You don't add that up across all the days. So how do we do that? How do we build this logic into Power BI? Well, we're going to use a few different measures that exist. Now, in this data model that I gave you guys, I went into SQL. I created a product inventory table that kind of simulates what we want to do here. And so in the product inventory table, I've created a table that has inventory levels. Let's go take just a really quick look at this to kind of add some context to the example that we're going to be working on. I've created a table. It's really just for one single product, because if I added in all the products, this would have become a very large. I'm clicking save real fast because I see a white screen here and it's scaring me. Let's go back over to customer table, refresh, go back over to product inventory. And that's not correct here. It's really weird. Let's look at unit balance. So we're getting values there. All right, so we're not going to be able to validate the table, but you see that there are values in here. Do I really have blanks? I must have blanks and didn't know it when I created it. All right, well, I think we have blanks. So that, oh, we do. We have blanks, so I tricked myself. So we do have some blanks, bad data. We can filter that out later, but here's what the data looks like. So every day, right, every working day of the year that's not on the weekend, we take an inventory balance. We see what is the number of balance, what is the number of units that we have in stock. So for example, on June 30th, 2005, we had 113. On July 1st, we had 118. But then you see that there's actually a 2-day gap here where we didn't take inventory level over the weekend, July 2nd or July 3rd. So when you're building out measures around this, you have to take this into account. This is not as simple as just sum of units balance. So we're going to go create real quick here a product inventory measure, and then I'm going to show you how to handle this scenario in DAX, and it's actually relatively simple. Clean this up. I'm going to clean up the table just a little bit here. I'll get rid of the slicer as well. Let's go ahead and create a new measure on internet sales. This is going to be our product inventory measure that starts us off. So this is just going to be a product inventory. There we go. And our product inventory is going to be our sum of the inventory from our product inventory table. So we'll start typing out product inventory, there it is. And we want to sum up our units balance. Now I know a minute ago I said you can't do this, and now I'm doing it, but you're going to see why. So the first thing I do is I create our inventory balance. That would be 1,000 separator. This is not a currency, so we'll format that as 1,000 separator. Now, if I put the product inventory into a table like this one right here, we know that the inventory levels are not going to be correct because it's adding it up across days, it's adding it up across months, and that's not correct. You always want the last balance. So if I drop product inventory in this table, you saw when we were looking at the product, it was actually only like 113, but now it's saying 2,630 because it's taking that inventory balance for each day of July and it's adding it up. We know that's wrong. So the first way that we try to tackle this within DAX is we say, return the inventory balance on the last day of the filter context. So if you're looking at July, return the inventory balance for July 31st, right? If you're looking at June, return the inventory balance for June 30th. And a lot of times that works perfectly. except for situations where you have blanks in your data. Like, so if you're the stock market and you don't work on certain days, or you don't take your inventory balance every, that throws another kind of wrench in the problem. So we're going to tackle both of these problems real quick. So the first one is, let's go ahead and create our closing balance. I'm going to create a new measure here on internet sales, and we'll call this something like product inventory closing balance, or just closing balance. Last date. And then we're going to say, all right, I want the closing balance for the last day. So that means we're modifying the filter context. So we're going to say calculate, and then closing product inventory. So return product inventory for the last day, not for all the days, just for the last day of the filter context. So we're going to use a function called last date. And what last date does is it just returns the last non-blank date. Seems odd. I've never read that before. It actually just returns the last date from your date table. So we're going to return the last date from our date table. I'll show you the last non-blank function here in just a moment. And we'll hit enter, and then we're going to actually format that as currency, English United States, of course. Oh, no, we'll do 1,000 separator. Sorry about that, because it's not a number. And now, if we look at that side by side with product inventory, you'll see the numbers are drastically different. So this is the last day. If you look at August, was August 31st, that would be 117. For September, our inventory balance on the last day of that month would have been 117. And then for October, it would have been 116. So what last date does is it looks at the date table, it grabs the very last day from whatever the filter context is. So right here, we're filtering our date table down to August. So it looks at all the days of August and it gets the last day of August, and then it returns the product inventory from that last day. So that's filter context. Now, you notice for July, we got a blank value. What's going on? Well, in July, it's returning the product inventory for July 31st. But we didn't take inventory balance on July 31st. It was a holiday, it was a weekend. Same thing in December, December 31st, right? It's New Year's. We didn't take an inventory balance. Everybody was at home with their families. So how do we handle that situation when you have blanks? Well, we can use another function here called last non-blank. And so with last non-blank, it's a little extra step, but we say return the last date that had a value. In other words, return the last date within the filter context that had an inventory balance. So let's go take a look at what that looks like real quick in our example. So we're going to create another new measure so we can see these kind of side by side, a little bit of comparison here. And on the internet sales table, we're going to create a new measure here. This will be called closing balance for, let's see, we'll call it non-blank. And now we're going to say calculate again. So we're going to return total sales within a modified filter context. Calculate, oh, no, not total sales, product inventory. There we go. And that is going to be for the last non-blank. And our last non-blank, the way that last non-blank works is it returns the last value from a column for which the expression is not blank. So it takes two parameters. The first one is the column that you want to return the last value from. The second expression is, okay, how do you determine if it's not blank, right? Is it by sales? Is it by transactions? Is it by customer? What is it by? So the first value we'll pass in here is actually going to be the date column from our date table. And then our expression is going to be product inventory, right? So if the date in our date table has an associated product inventory from the product inventory table, it's not blank. But if we look at the product inventory table and there's no date that corresponds to that, then it is blank, and we're going to ignore that. So in this example here, we're going to return product inventory for the last non-blank date in our date table. Right? So very similar to last date, but we're not grabbing the last date, we're grabbing the last non-blank date. So if we hit enter now, this is going to, within the filter context, find the last date that's not blank. So let's take a look at that. We're going to add it to our table real quick, like so. And the difference here is that when we're looking at, for example, July, you see that July now gets a valid value, whereas before it was blank. Same thing is true for December and any other dates where there might have been a blank value. So right here, what this expression does, closing balance date, it grabs the last date from the date table. So it looks at July, it grabs July 31st. And it returns the inventory balance for July 31st, which there wasn't one because we didn't take one. What last non-blank does, which is this expression right here, is it looks at July and all of the dates for July, because we passed in the date column from the date table, and it checks to see what was the last date in July that actually had a value. So it looks at July 31st and it says, nope, you didn't have an inventory balance, so we're gonna kind of skip that. Then it looks at July 30th and it says, okay, there was an inventory balance for July 30th. So then it returns our inventory balance for July 30th. And so this is a way of kind of handling semi-additive measures when you have blanks in your data. If you don't have blanks, it's really, really easy to handle semi-additive measures, because you could just write that original expression where we return the closing balance for the last day. But if you do have blanks, it requires a little bit more work, and that's what we did here. We just used last non-blank. Now, if you wanted to return the first balance of the month, right, from the first day, you would just replace last date with first date, and you could return, for the first non-blank, you would return last non-blank with first non-blank. So you'd rewrite that expression, and you'd get the first day instead of the last, right? So that's how that would work if you were trying to return that for semi-additive measures. Now, there's a lot more you can do with this. Opening balance month, closing balance month, opening balance year, closing balance year. That'll kind of give you some of the same functionality. In fact, I'm looking at my notes. I think we have one more semi-additive measure we're going to do here. And let me make sure we have a good amount of time to do that. And we do. So we're going to calculate our inventory balance. That's let's do opening balance for the month. Now, if you want to do opening balance for the month, technically your opening balance for this month is the closing balance for last month, right? So if you want to bring back your opening balance for this month, it's the closing balance from the prior month. So it's not first date from the current month. That wouldn't work. That's just the balance from the first day of the month. You have to actually go back to the prior month and bring that in. There's a couple of ways to write this in DAX. The easiest way is a function called opening balance month. So I'm going to show you that first. Then I'm going to show you the alternative method that handles blanks. So let's do opening balance month real quick. And I think with about 20 minutes to go, we have some time to do both of these, do one more example, and take a couple of questions here at the end. So it's going to work out perfect. We're going to do opening balance month. And opening balance month is going to, once again, actually, I always want to start with calculate here, but we don't need to. So I'm going to type in opening balance month. We'll go over here and say we want to return the opening balance month for our product inventory. So what was the product inventory at the beginning of this month? Whatever it ended for last month, right? So we're going to do that. And then you notice here it says you have to pass in your dates column from your dates table. And this right here is a beautiful expression. Once again, if you have data and you have a situation like this where you have to return balances for whatever the balances might be, and it's a semi-additive measure, if you do not have blanks in your data, this works, and you do not have to worry about the next example I show you. Although the next example still works for other scenarios too, so it's a good example. And so we're going to return the opening balance for the month. What opening balance month does is it automatically goes back to the prior month. It gets all of the days for the prior month, and then it grabs the last day of the prior month. And then it returns the product inventory for the last day of the prior month, and that's what becomes your opening balance for this month. So that's all it does. It goes back to the prior month, gets all the days, grabs the last day, and then it gets the product inventory for that last day. Now, you might have noticed it's doing the same thing that last date kind of did. It just grabs the last day. So if you have a blank, it's going to return blank. Let's take a look. We're going to go ahead and drop opening balance month right here in our table. And I need to clean up so we can see everything right here. And then you'll see it's working exactly the way that we kind of want it to. In fact, let's get rid of total sales so we can see it a little bit better. All right. So this right here, closing balance, last non-blank, was a closing balance of June. That closing balance of June is the opening balance for July. Perfect. That works great. But then we get to August, and we're like, wait a minute, we want to return the opening balance for August, and it says we have no balance on August 1st. Well, that's not correct. We know we had a balance back in July. Why would we have no balance? The problem is that opening balance month, opening balance quarter, closing balance month, those functions, they do not automatically handle blank values. So therefore, it's doing this. It's doing the same thing that this last date function did. It's looking at July, it's getting July 31st from July, and since July 31st had no associated inventory balance, product inventory, it's returning blank. So how do we fix that? Well, it's a little bit more code, And if you really want to dive deeper into this, we go deep into this stuff in our DAX boot camps. That's definitely the place to learn this and get a kind of deep dive into it. A lot slower, more hands-on experience. But I do want to show it to you. I want to give you this tool in your toolbox so you can go back and try this out yourself. So let's build another calculated measure here on our internet sales table. And this one is going to be our opening balance month, non-blank, right? And so we have two more measures we're going to build. This one and then one more. And then let me zoom in too. All right, come on, non-blank. There we go. I can tell we're reaching the end here. I'm wearing down. All right, opening balance month, non-blank. And for this one, what we need to do is we're going to manually have to go back and get the list of dates from the prior month. So the function that does that is parallel period. Parallel period will go back to the period you specify and get all of the dates from that period. All right, so if we use parallel period right here, and then I pass in the date column from my date table, what this is going to do is it's going to look at our date table, and it's going to take the current filter that we're at, and it's going to go back to the prior month. So we're going to tell it -1 month. And so we're telling it, look at the date table, go back 1, and then you specify your interval, which is month. So you could use the same thing for opening balance for the quarter. You would just go back to the prior quarter. Opening balance for the year, you would just go back to the prior year. This is extremely flexible. So parallel period returns all of the days from the prior month. Now, I could say, all right, now that you've gotten all the days from the prior month, grab the last date. This is kind of what opening balance month was doing. It's grabbing the last date there, like so. But we don't want to do that. If we grab the last date, we know sometimes it's going to be blank. So what do? Well, we already know. We use last non-blank. So we're modifying the dates with parallel period. Then we're going to use last non-blank and say from that list of dates from the parallel period, so that's going to be, let's say we were looking right here, right? We're trying to solve this problem for August. So parallel period, if you're looking right here at this cell, the filter context is August. Parallel period goes back to July, and it gets all of the dates for July. Last non-blank then says, okay, you've provided me a table that has all the dates for July. Last non-blank will go get the last date for July. Kind of like what closing balance month is doing right here. So we're going to say last non-blank, and that takes two parameters, right? The first parameter is your list of dates, or your column rather, and then an expression to determine if it's blank or not. And ours will of course be product inventory. And so we're very close to actually being done with this measure. That's the hard part. The easy part is we now want to calculate. So this is our filter portion. So this is going to be the filter part of calculate. And so up here we're going to say, all right, calculate or return our product inventory for this modified filter. If you were to put this in a sentence, in fact, what you would say is return product inventory for the last non-blank of the prior month. And that's exactly what this calculation right here is doing. It's giving us exactly what we want. So let's take a quick look at this. We'll add another closing parenthesis here, hit enter. And so unless I mess something up here, sometimes I'll miss a parenthesis, I'll put it in the wrong place. We should be good to go. So let's grab that. We'll drag that over real quick, and we're going to take a look at this. All right. So you'll notice that right here we get a blank value, and that's okay because we didn't have any cells back in May. That never happened. But every day after that, we have an opening balance that is the result of the prior month. So let me zoom in on that and take a closer look. Here we go. All right. So our new calculated measure that we created, I know there's a lot here. If you're brand new to DAX today, we just dove into the deep end. I understand that. It is a very elegant language. It's a very simple language, but there's obviously a lot more you can do. This measure right here, what it's doing is it's going back to the prior month, getting the last date from that month that was not blank, and it's returning that value. And so if we're looking at July in our table right here, we're trying to get the last non-blank from the previous month, which is 113. It's perfect. If we're looking at August, we're getting the last non-blank from July. And so that gives us our opening balance for this month. Really cool, really great solution here. There's a lot more to learn around parallel period versus date add, same period last year versus previous period. There's a lot more in DAX than what we cover in this workshop, but this gets us very far. Now, I'm going to broach ever so slightly the most complicated topic, in my opinion, in all of DAX, and that is a topic called context transition. We talked about two things around evaluation context in this class. The first thing was we talked about row context. Row context is when you have an operation like a calculated column like a filter function or one of those X functions, my favorite functions in DAX, that iterates over a table, meaning it works on one row at a table at a time. And when you work on one row of a table at a time, you are performing an expression on each row of that table. So that expression only sees that row. That makes sense. That's very logical. But there's a side effect. The side effect is that row filter, which is the active relationship in the data model. We talked about the fact that it was deactivated, right? And we worked around probably 3 or 4 examples where we used navigation functions, related and related table, to say, hey, use the relationship that exists. Well, context transition is when the row filter gets added to the filter context. And that can happen a couple of different ways. It can happen automatically, or it can just happen because you force it to happen. And this is without using related and related table. That's the interesting thing here. So let's take a look at a quick example here. In my notes, we actually go over and look at the customer table, which is perfect. So on the customer table here, earlier in this class, we created a calculation that was pretty involved. We created a calculation using maxx, related table, and there was a lot going on here that we had to explain. And for most students that are brand new to DAX, you're not going to understand this the first time you see it. You kind of got to work through it a couple of times. We could have written this with calculated context. By forcing calculated context to occur, we could have written this a lot easier. Let me remind you of a couple things here, right? We're going to create 2 calculated columns on this table real quick so you can see something that's really interesting. We're going to create the first calculated column on the customer table. It's customer table. And it's going to return the maximum date. And you remember what this does, right? We're going to call it max order date. And if I type in here max internet sales and then order date, what that returns from our internet sales table is it returns the maximum date for all records because there's no filtering going on, so it sees the entire table and it grabs the very last date. That's because we're in a row context. So that's the first column we're going to create. Now, I want to show you context transition and how this can make your life a lot easier, and sometimes, unfortunately, in more advanced calculations, when you're authoring more advanced calculations, it can make it a little bit more difficult as well. To really highlight this, I do have to create a measure real quick, and the measure is going to be this code. In fact, just so you know, this is not a trick, it's not sleight of hand, I'm going to copy that code right there. I'm going to copy that code, and then on the customer table, I'm just going to create a measure real quick, and the measure is going to be called max date measure, and then I'm going to paste in that code that I copied a moment ago. It's the exact same code as the column, all right? Now the problem is whenever a calculated measure is called, it gets wrapped in a calculate statement. And what calculate does is we've talked about how it allows you to evaluate an expression within a modified filter context. It also does something else that can be really confusing. It actually takes row filters that have been kind of deactivated, like we talked about, and it adds them to the filter context. And if they're part of the filter context, you're going to get completely different behavior than what we've seen so far. And so technically, this calculated measure that I just saw is wrapped in a calculate, which will force context transition to occur. The simple definition that I use for context transition is it's when a row filter gets added to the filter context. I like that better. It's a little simpler. So watch this. We've got a calculated column that we created here that returns the maximum order date from our internet sales table. We're going to create one more column on this table. Right click, new column. And this column is going to be called max date using measure equals, and we're going to, instead of type max order date from the internet sales table, we're actually just going to return our measure that we created called max date measure, which is, if you remember, it's that exact code. It's the same code that we used in our calculate column. But implicitly behind the scenes, the DAX language wraps that in a calculate because it's a measure. So we're going to hit enter. And we're going to go over here to the right. And you're going to notice the results are different. And this is surprising, right? This is surprising. So this is context transition. The filter that was on the row that was previously deactivated because we were working in a calculated column, that calculated measure is wrapped in a calculate, and calculate says, hey, you know what? I'm going to take that row filter, I'm going to add it to the filter context. So now that row is filtering down the internet sales table, no problem. In this situation, this is awesome, right? Because we don't have to write that really complicated expression like we wrote over here, where we said max X, related table, internet sales. It's a little bit more confusing. we can just say return the max internet sales order date, but it's inside of a measure. Now you say, well, Mitchell, I'm not quite sure that's correct. Can you show me another example here? I can. If you look at max order date right here, just to be very, very clear, it's returning the very last date from the internet sales table over and over and over again. Right there, right? Well, what we're going to do is we're going to wrap that expression inside of a calculate. So watch this. If I come over here and I just wrap that in calculate and I go to the very end, that is going to force that date key, the date that the relationship is on, to automatically filter down internet sales. So the row filter gets added to the filter context and it just works like magic. Once again, sometimes when context transition is introduced, it's a great thing. It makes your code a lot easier to write. Sometimes it's really, really bad. The other example takes a little bit of time to work up to, so it might have taken the whole couple of hours we had together here today, but that's something we cover in our other classes and in that DAX bootcamp. Now, if I hit enter right here, and we go all the way over here to the right, let me see here, all the way over to the right, the measure that we just modified was this one right here. It no longer shows 731 all the way down. Instead, it shows us the exact examples, and that's because the row filter is added to the filter context, and it's now able to filter down the internet sales. It's now active. All right, that brings us to all of our demos. I don't know how we did it, but we got through everything that was in your notes. Remember that if you downloaded these class labs, 2 days ago, I would highly encourage you to download them again because the examples that I went through were ever so slightly modified. I'm going to throw a couple of things out there. Remember that if you attended this and registered for this event today, you'll get 20% off of our on-demand learning courses. And also I would encourage you, if you really like this, take a look at our DAX boot camps that are down in the description of this YouTube video. So in the description of this YouTube video, we have the links to those DAX boot camps that are coming up. This is a pretty big event, so I would not expect those seats to stay open very long, but I'm not a salesperson, so do what you want to do. Survey link, yes. The great thing about the survey link is it tells us what you want us to do in the future. That's in the description as well. So let us know, what are events that you're interested in, because we're going to start doing these more and more, where we do these 3-hour sessions and we're just giving back to the community, and we want to hear from you. What are you interested in? And then I'm going to hold back for a few minutes, and I'm going to see if Brian over here has any questions for me that I can answer, just to kind of wrap this class up. As always, thank you guys for joining us. Check me out on YouTube at just Mitchell SQL, Mitchell Pearson. Check out the YouTube channel. I'll be dropping a new DAX video every week, and I enjoy doing that. All right, Brian, do we have any questions?
Well, a huge shout out to Peter for answering a lot of questions in the background there. I think you know Peter also from the Nerd Boot Camp.
I do. So Peter Smits, thank you. Thank you. We have quite a few people. When you're in an event like this, there's a lot of attendees. Appreciate everybody who is helping out with answering those questions. And thank you, Peter, for jumping in there and helping out as well.
But no common question. I think you got most of them answered already.
Wow. No common information. Let me I saw some people asking for my contact information. If Matt is still on here, he can throw that in the chat window, but I will actually share my PowerPoint as well. And like I said before, Mitchell Pearson 1 on LinkedIn. Please feel free to connect with me. I talk with a lot of people on there all the time. Connect with me on Twitter. Email me if you want, ilmpearson@pragmaticworks. And like always, I just want to tell everybody, thank you for joining us today. I hope it was helpful. I hope it was informative. I got yelled at a couple times for going too quick, but it's recorded, so you can definitely go back, slow me down a little bit, and enjoy that. So if we have no questions, Brian, I think we are done.
Sounds good. I'll go ahead and stop the stream now. Thank you so much, guys.
Thank you, everybody.